Okay, everyone, thanks for the patience. Here I am. Everyone, can you hear me? Yes, okay. So this will be just need to write here. This will be the first time I try. There is no TTS for now because it will be a mess if I try to talk to Matt and to you at the same time or listen to you both. Yeah, I changed the channel name. Here we go. I changed the channel name to bitluni Live because it's not trash anymore, and I'm not uploading anything else. So Matt is on here in the back room already on Google Meets. I never tried it before. I need to like add him as a source, and then video capture, window capture. Here we go. Yeah, oh, this is Matt. Nice. Okay. Match title, client area. Yes. Okay. I think this one. Here we go. This is Matt Venn. He's the genius behind. I need to put you behind the chat though. How do I? So we need to share the space up. How do I clip? Okay. Here you go. Now you have a narrow piece of window. And I need to use this. Okay. So Matt made it possible to basically can I? Yeah, I put you also on audio here. So can we test? Can you say something?
Check. Hello.
Yes. Okay. So we can hear you now as well. I hope the chat can hear you as well, or the stream. And oh yeah, you got a SuperCon mug. Yeah, mine is. I don't know where, but mine is not here. Loud and clear. Okay, great. So basically, the title says that I will make an ASIC live today. And this is only possible because of Matt. Matt here, this way around. He made something. Maybe you explain it yourself, Matt. So.
Yeah. I love to take the credit, but there was loads of people that I built this all on top of. So it definitely wouldn't be possible without like the open source FPGA community, for example. But yeah, what I've been working on is trying to continue to lower the barrier to entry to ASIC stuff. And the one of the latest projects has been this thing called Tiny Tape Out. And the main thing that we're doing there is lowering the cost to play with the tools by having all the tools in a GitHub action. So you don't have to download gigabytes of tools on a Linux machine. You can run them on the cloud. And the other thing is, it can be a bit overwhelming. If we've got these chips. They look small, but they've got 10 square millimeters of space, and we've measured the size of a flip-flop earlier. What was it? It was like 14 by 7 microns for Sky 130. Yeah. So you can fit like 600 of those in a space that's like 100 by 150 microns. And on the whole chip, you've got 10 square millimeters. So you can put thousands and thousands. So it can be overwhelming to know what to do, and also expensive. There is the free Skywater shuttle run sponsored by Google, which is run as a lottery, and that's got maybe a 2-to-1 contention now. So 80 people applied for the last one. If you're lucky, you get in. You get like 300 chips, all with your own design on it. I just got my results back from MPW2, little maraca shake of lots of ASICs there. So what we're doing is we're buying a shuttle for $10,000, but then we're putting 250 or 500 designs on there. And then that means we're guaranteed to get the silicon. And it means that we can split that expensive cost down between like 250 or 500 people. So the cost to put a design on is $25, and the cost to get your design on a chip and put on a PCB and sent to you is $100. So that's what we're trying to do with the with Tiny Tape Out.
So if I got it right, it's basically what you're working towards is like jail CPCB, but for actual ASICs. That's my comparison for that, because it's like already quite cheap. I mean, it's still substantial for like if you want the actual IC or the resulting board, which we will just take on a look in a second. But that was like unheard of like a few years ago, that you can even make your own ASIC.
Yeah, I mean, one of the big problems with the ASIC stuff is how long it takes to get your feedback. So that's like another thing that we're working on. I don't know if you saw SillyWiz, but SillyWiz is trying to get like quick feedback on the analog design stuff. And if you're doing digital stuff, you can use FPGAs to make that faster. But like these ones, I sent these off like a year and a half ago. They took a whole 18 months to get here. And that's slow because we're just beginning, and it's like a new process, and there were lots of mistakes made at the beginning. But for Tiny Tape Out and for MPW 7 and 8, I'm expecting and hoping for less than 6 months. But still, that's a lot longer than a PCB from OSH Park.
Okay, yeah, that sounds like we could fight the chip shortage with 6 months.
Yeah, well, I mean,
lead time.
You know, the lead times have been longer than 6 months. So if anyone wants to make like an STM32 alike,
okay, unfortunately, on Tiny Tape Out, as a name suggests, it's tiny, so
too tiny.
STM wouldn't fit. But still, I was surprised, since I pitched already like the design that I want to try earlier today, and actually that's a few flip-flops we got there. So. I can set. I will explain later what I want to try, because we need to be fast. So anyone who wants also to try it, I can switch, maybe show how it looks like, the page. So if you never visited the page tinytapeout.com. Screen capture, here we go. Oh, okay, here we go. So you got all the resources there. Am I right? You don't need like very much. You have basically a complete simulator in the browser here, and you can play around with the puzzles and whatnot. Did I get it right, Matt?
Yeah. So yeah, we're kind of aiming for people. Well, kind of like two groups of people. Some people that already know a bit what they're doing, and they may use Wokwi, which is this online simulator that Uri Shak had made, or you might use like an HDL like Verilog or something. But for the people that don't know anything, we've got this on the left-hand side there, this digital design guide, and the idea is you work your way through there until you've like got an idea about what you might want to do. So the thing that I was thinking of doing with you was scrolling down to one of the customizable designs, like the padlock or the UART.
Okay, padlock or UART. I mean, UART, we can maybe let it like shift out pre-configured text or something.
Yeah,
so,
for example, yeah.
Yeah. Okay, so this is it is like a puzzle to solve, or okay.
Could be. The idea here is just like a bit like an off the peg design. So if you're stuck for an idea, you could take one of these designs
Yeah.
and then customize it yourself. So maybe if you take a look at that, one of these ones, yeah, there's like documentation here on how you would actually go about customizing it to set the bits to be what you want, and then the data flowing through that shift chain. And then at the moment you're in edit mode, and then you can press that green play button. It will shift into simulation mode.
Okay, I'm in simulation now.
No,
and
yeah.
We see some
I'm
debug
watching it
output
like
here.
I'm watching with a 10-second delay because I'm watching.
Okay.
Yeah.
Sorry.
Um,
Okay.
Yeah. So let's just say that you did make a customization.
Yeah.
And we'll run through like what the steps are involved to actually then see that turned into the GDS files that are going to get put on the ASIC.
Okay. So I could what?
So I think this one is programmed. If you have a look if you zoom in a bit to the muxes, you can see that they're either connected to VCC or they're connected to ground. So that's how you're programming a 1 or a 0 into this long shift register.
Oh, yeah. Okay.
Yeah, see that one. Yeah. So by choosing what those, whether it's a 1 or a 0, you're like setting that byte.
What's the difference between the triangle and VCC?
The triangle is ground, the VCC is plus. So it's a setting. So that's setting a 1 or a 0. So when the flop,
okay, yeah, I'm confused. I always had the ground pointing downwards. Okay.
When the flip flops are programmed, they're going to get programmed with that pattern. Yeah. Okay. And then basically in WOCWI, everything between those two green circuits boards is going to go in the ASIC, and everything outside is like stuff you can use for testing. Okay. So we've got that dip switch on the left, and we've got the 7 segment on the right.
Maybe we can show like the board that will be resulting from that, if we where we can see an image like in the screen.
Yeah, that one. Yeah. No, the top, right at the top.
Yeah. Is there a pic? Okay. So you fit. So what your part is to at the end is to take all the designs that the people submit and then put like individual. The carrots here are all individual designs, and the limitation for now, what I see is that we have like 8 input bits and 8 output bits, and and we have to also put a clock on one of those input bits as well, and they are like shifted through all those designs. So unfortunately, like the input and output, this is cool to see. So this is a rather complex design, and here is down there is like there
you go. You can see like one that's got a lot of utilization and one with hardly any.
Yeah. Okay, and I saw like from the first round of we have like 4-bit CPU with like 4 instructions, which everything is like on GitHub here, and there's also an FPGA implementation, which is quite interesting because
there's actually 2 FPGAs on Tiny Tape Out too.
Oh, really? Okay, on Tiny Tape Out too. And so the maximum hertz rate. Let me switch to Windows again. Okay, so the maximum frequency that we can get on the inputs is like in 10 kilohertz range.
Yeah, something really low. Yeah.
Okay, but still on the IC, the processing can go up to gigahertz.
Yeah, the processing. Yeah, so the speed, the limitation is because we've got so many designs in a long serial chain. So we have to capture the 8 inputs and then like pass them through the chain and then put them into the design that is currently selected. Grab the outputs and then bring them towards the end of the chain and then put them on the outputs. But it's easy to get up to gigahertz frequency on this 130 nanometer process that we're using, this open source PDK from Skywater. So what one person has done as an experiment on Tiny Tape Out 2 is they got a ring oscillator, and that can oscillate at like many hundreds of megahertz, and
So
then you can count.
How does the oscillator work? Is it just inverting, like inverters in chain, and then
an odd number of inverters in a loop?
Oh, okay, and then the output will always like flicker.
Yeah.
So what I saw, it was even linked like in the examples or something. If you take a look at the, I had it opened on GitHub. I might have it here.
I can drop a link to the current
this
data sheet into the YouTube.
I have
comments. I don't know whether it's going to let me post a
screen
link.
capture. Whoop. Oh, if you type anything, I give you moderator rights. Otherwise, you won't be able to link anything.
I just typed in the YouTube. Oh yeah, that's the one.
Okay.
Yeah. So there's something going on very fast inside that small design, and then some registers counting the number of times is cycling, and then being able to take like the most significant bits of those registers and put them out on the output. So you
saw it made like a shifted right by 24 by 32 and so on, something like that, like really high dividers, so you can see if it's actually counting or not, or if it's stable oscillator. So once like we get the results from like this design, we might be able in future to have, even though like that the input output frequency of the IO would improve, we still might have like a template for a faster stable clock inside of the ASIC.
I think it's, to be honest, I think it's more likely that with Tiny Tape Out 3 we'll move to a completely different way of addressing the designs, because I'm not a great like RTL or Verilog programmer. I just put together something that I was pretty sure was going to work. And actually, it probably wouldn't have worked, but I got some help spotting the problems and fixing it up. But you can do something much, much faster with like a more kind of rows column way of addressing the IOs. And there's no reason we couldn't get like 10 or 20 or 50x speed increase on the IOs for round 3. But I'm just, we've got to focus on Tiny Tape Out 2 first.
Okay, this was now a little bit all over the place. So what are the steps that I can submit? On Friday is the deadline to submit a design. So everyone who's interested in getting in getting a design, like Friday, but it's still possible. So if you're cheeky to get like in this round, get a first like test or whatever. The community is like also quite active on your Discord. Can you drop like a Discord invitation link or something in the chat, or just I need like your name to set it to moderator so you can paste links. Just say hello and then I will. If you
I already said hello on the I posted a link to the PDF on the chat.
Yeah, I don't see that. Unfortunately,
how do I do it?
Wait, live chat. Maybe it was. Yeah, it was. I can see. Okay.
Or you could invite me to your Discord.
Yeah. My Discord is discord.bitluni.net. I think, I don't know.
This is where we find out it's easier to make an ASIC than it is to join a Discord.
This is basically Matt's Discord. Here we go, and mine would be, I think, link. Matt's Discord. This will be the. I hope it is. Yeah, I hope it is. Okay, so on your Discord, there's like a community. What I saw from the puzzles here, there's something like padlock, or people are like interactively like putting designs on this IC, because if we get where's the picture of the testing boards making ASICs? Wait,
What channel are you all posting on?
on the YouTube chat.
Okay, right.
Yeah,
Oh,
sorry.
I thought you were posting on Discord. And
No,
it was going
YouTube
to-
chat, because the viewers that are not on Discord right now, they
Okay,
won't be able to find it. So
Okay, right.
YouTube chat would be nice.
Yeah. Well, make me a moderator on this chat then, and I can post stuff here.
Okay. Okay, here we go. You're moderator now.
Moderator.
Truth.
Anyway, it's fine. I can always post you links on the Discord, and you can be my forwarding service. Yeah. So
or maybe you just show in the camera how it looks, the board that you made, the testing board. Do you have one?
No, they're proof of concepts at the moment.
Okay, great. Nevertheless, there are like 200 designs, or more. How many are on one board?
Tiny Tape Out 2 is going to be 250, but we've only got 100 designs on there at the moment. Actually, it went up to 101 today.
Oh, nice.
So I'm expecting a little bit of a bump by like tomorrow. No, not tomorrow. Friday. Friday tape out deadline, 6 p.m. Central European time. We'll see what
people
happens.
are using like until the last minute. Oops, sorry, I stretched you. I tried to unclip you. Okay, but people are trying still to get like the most out of their designs until the last minute, and we can join. So I certainly
Welcome.
will. I certainly want also to submit something serious, and now I will just try to get you help where to start, because there is like, I mean, it says everything in the tutorials here.
Yeah, you shouldn't. It's all meant to be like completely self-paced, and then we've got the Tiny Tape Out Discord for like to help people. If they get stuck, but I thought it'd be fun to like just do like a basic submission and walk it through it with you. So if you go to like the homepage again, that's like where you start. You start at the top of the homepage, and then you work your way through to the bottom, and then by the time you get to the bottom, you're ready to submit.
Okay. Wait. Runs. Stop of the page. Okay.
And basically, you want to scroll down to get started, and then create your own design with a Walkway template, or for advanced users, an HDL. So you've got to choose whether you're going to use Walkway, which is like the drawing schematic editor, or an HDL.
Wait, where? Okay, guide, getting started. Walkwiki. No. Okay, you watching me delayed.
Yeah, it's difficult. And then I think because we've already got the design, we'll use that that LED one, the customizable one. We'll leave your designing for later.
Okay.
So let's just
the
pretend
UART is quite big for the display. Maybe we just do the 7 segment. That should be. Oh, it's also big, but I mean that's like more. It's okay. Let's try that.
So that's our design. We've already got that.
Okay.
But if you were wanting to do this, you'd use this as like a jumping off point. Yeah. So let's just pretend that you've made this really quickly.
Okay. Yeah.
And if you scroll this page down a little bit,
I can break it. I see. I can break. How do you turn on the grid?
in the
What's
three dots.
G? Oh, G. Okay.
Okay.
Okay, there is the grid.
And you see underneath it says, well, it will stick
Okay,
together. As when you let go, it draws the wires, so don't worry.
Oh, okay.
Yeah.
So it rewires everything.
Yeah.
So we can edit here.
Yeah.
And duplicate. There's like a D is duplicate, not control D. Okay. And then well, we can add stuff. How do we wire with W? Or
Well, let's just leave this for now. We've got like, if you wanted to do this, there's like the video, the getting started video with Walkway.
Okay. Okay, great. So we can. I just wanted to show that we can edit from within here and change the design or make a new design with logic gates. So a simple logic design.
Yeah.
Okay. What's next? What's next?
Then,
I can save it.
Yeah. So if you to get the idea, if you click that, see the link underneath, trouble viewing this simulation, click on the thing, that will pop it out to a new window.
Oh, sweet.
And normally when you're working on your own design, you're working with it full screen on a new window.
Okay.
And you see that when it's in the browser, you've got this URL at the top that ends with a bunch of numbers. And that's the ID of your walkway design.
Okay. And is it already like bound to my account, because I logged in with like GitHub before the stream? So
no, you'd have to save this.
Okay, so I can basically save a copy of that design. Oh, wait, you can see that. Sorry, I will shift the window a little bit so we can see.
You can minimize that left-hand side. You don't need to see
okay, here you go. Save copy, and now we got a copy, and this is my.
And that number at the top is your unique number.
Okay, and others will also be able to access that.
Yeah, they'll be able to pirate your design and rip off your amazing
idea. Okay, so one thing is that everyone who orders like this board where one of the ICs is mounted with all the 250 designs or 101, who knows, you will be able to try out all the designs. You can switch the design, like configure it with dip switches, or how do you select the design?
Yeah, you select which one is active with the dip switches.
Okay. You select the design, and then you can run your design, or you can try out the puzzles of the other people on the trolls and whatnot that submitted also other designs from the community. So it's a neat thing, because you can see like many designs already on GitHub and check out what other people try there. And basically that will be, I think, a quick evolution, because every one round takes 6 months. But then after that 6 months, if we have like 200 designs or 100 designs, all the 100 people learn from each other, and that evolves way quicker than everyone working on their own. So it's a neat learning platform, or I'd say testing or prototyping, or I don't know, an introduction into ASIC design. Okay.
Yeah, it's a fun way of like playing with all these other designs done by like. Some will be much simpler than your design, and some will be way more complicated. So then, but having like your own chip with a data sheet that's got your design and all the other designs on there, I think that's going to be super cool. Really looking forward to that.
that will be a unicorn IC with 200 different functions.
I mean, these ones that I just got back from MPW2, these were the first ones from my 0 to ASIC course, and that was the first 14 people that took my course who got 14 of their designs on. Plus 2 of mine.
Oh, okay.
So that's like that was like the roots of Tiny Tape Out, and now we've just blown that number up from 16 to 250.
That's cool. Okay, and I hope some people like, or I will try to get one design on there, Persistence of vision. I thought we will vote on something, but I came up with a design that will totally work at 10 kilohertz input output perfectly fine, and it will be basically an IC that is able like to that you can put on a fan and then generate a persistence of vision text or graphics or whatever with like 64 columns maybe. If it fits, we will see how many columns fit on on the actual space, and one column has eight rows. That will be cool. Super simple project, and I think I started even on Verilog, which is also a way to submit a design, but we will try one with this here first. So okay, I started. I'm stalling here. I'm sorry, Matt.
Yeah, that's fine. So, and just to respond to some of the people in the YouTube comments, they're suggesting things like 741s and 555s, and it's worth saying that tiny tape out is just digital for now, but we do want to add analog later. And if you want to find out what we're doing to address the analog approachability, then you should Google Silly Whiz. And you can see a video that I made recently that demonstrates our new tool.
Okay.
So yeah, bitluni. Let's copy that. Go keep that page open.
Yeah.
Go back to the home page and scroll down to get your submission ready. And then underneath that video, there's a link that says GitHub submission template.
Wait.
Yeah, class D 741, exactly. We saw there's a Sigma Delta A to D and D2A on Tiny Tape Out 2. Back on the home page. On the guide,
and then
top, like the top link, and click on the picture, the Tiny Tape Out logo, right at the top.
Okay, here we go.
Home page.
Yeah. Oh, there is the timeline.
Yeah, and then scroll down to getting your submission ready.
Get started. Oh, yeah, okay.
And then underneath that video, it says GitHub submission template.
Okay, great. So I go there. I'm logged in.
It's so frustrating seeing you 10 seconds behind.
Okay, I clicked on the link, and then
okay.
I will code, and do I git?
Yeah, then you want to fork that repository.
Fork it. Okay, I never forked anything.
Fork it.
How do I? Where is the fork? Here is the fork button. Okay, I fork it.
Fork it.
Tiny Tape Out 0 to submission template.
Yes.
Do I change the name? No.
Well, you can change it to Looney's design, or it's up to you. Yeah.
Okay, not submission template. It will be basically live test because it's okay. Description. Okay, create fork.
Yeah.
And then we just need to put the
and
then
so this is all explained in the video for people like worrying that we're skipping around a lot. Everything is really clearly explained, much better than what we're doing now. And what you need to do is now edit that info.yaml file. So click on the info.yaml.
Yep. Here we go. We can
and then
direct.
With the pen, edit it.
Here we go.
And then you want to take that ID from your Walkway design and paste it into the bit where it says
what? Really? That's all? No. Are you kidding me? And where do I paste the Walkway? Okay.
Top where it says Walkway ID 0, that's where you paste in your ID for your actual design.
Oh yeah, here we go. Okay, I need to get this ID here.
Yeah.
Okay.
And then
and that's all.
Yeah. To actually make a submission, I'm kind of forcing you to fill in a bit of the documentation stuff because having the data sheet with all the info is like really cool. And that was one of the things that we learned with Tiny Takeout 1 is if we didn't do that, people didn't do it, and we had a really like bare bones data sheet with only a third of the designs documented.
I don't know what my Discord handle is. Title.
Well, you don't need it for now. Like you can come back to it later. The only thing that you need is that ID. So once you've got the ID in, you can just commit this file.
So what is mandatory of those here?
Nothing for running the GDS action.
Okay, commit changes, and then how does the actions?
Yeah.
And then...
and then we've actually got to do I've got to walk you. This is going to be annoying as well. On the settings, let me just load it up so I can talk you through it. On the settings of the repository, you've got to go to actions. Oh no, pages.
Pages?
Yeah.
Or actions?
No, pages. Sorry, I got it wrong.
Okay.
And then it says build and deployment, and you've got to change it from deploy from a branch to GitHub Actions.
Okay, GitHub Actions. Nice. Yeah. Okay, change that.
So what that does is it means that when the actions run, it can publish like a mini website with the results of the run.
Oh, cool. Yeah.
Yeah. And now click on actions, like the tab at the top.
Okay, actions here.
Yeah.
Okay.
And you may need to enable the actions.
I understand, and go ahead, enable them.
Yeah.
Okay. So this is also my first time introduced into actions. I mean, I heard some stuff about it. Sniff, who's also in the chat right now, he made things running in the actions before. Okay, what next?
Okay, I'm waiting to see what your screen is showing.
Okay,
please wait
it's showing
10 seconds.
all workflows, and there is 0 workflow runs.
Okay, yeah. So click on the. So I think if we had done it the other way around, like I show in the videos.
Oh no!
Then we would have already done this, and when you made that commit, it would have triggered the action. But because we didn't have the actions enabled, so if you click on the left hand side, you've got 2 actions, docs and GDS. Click on the GDS one. Okay, and the GDS is like the name of the files. They're a bit like Gerbers for PCBs, but they're for ASICs.
Oh, okay. Docs?
No, GDS.
GDS.
Yeah. And then you should see an ability to, maybe on the right-hand side, run workflow button you can click after you've selected GDS.
Main run workflow. Okay, I just... This workflow has a workflow dispatch event tree. Oh, something showed up. It's cute. Yeah. It's cute.
Yes. So then what this is going to do is basically it's going to be like, okay, so let's load that info.yaml. Okay, it's a number, so that means it's a Wokwi job. So fetch. So one of the things that Uri did to Wokwi was he made it so that it added to the API. So if you call the API with the ID of the project, it basically exports the design between those 2 green PCB blocks as a Verilog netlist. Downloads that, and then that gets run through OpenLane. If you click on that,
works. And that works like with a simple action on GitHub, everything works fine there, or what?
Well, we'll see.
So what happens? Okay, what happens if you have like added LEDs in that circuit?
They'll all get anything that doesn't get translated to a standard cell, like an AND gate or an OR gate or a flip flop, is just going to get chucked out.
Okay.
If you click on the running GDS job, you're going to be able to get a bit more information.
Oh, interesting. Okay. It's doing something. Status in progress. Do I have to pay so this runs faster?
No. But one of the cool things is because GitHub gives you free compute for open source projects.
Yeah.
So that means we're kind of, Microsoft is picking up the bill for our ASIC design.
That's cool. That's cool. And the best part is that somehow we don't need like anything you provided. Basically.
What we've seen is that when people do like bigger designs and it takes like longer, like 30 or 40 minutes to iterate, people often like to do a local install of the tools when they're really into it. But you can imagine for a school, not having to download anything is a huge win, because that means you don't really have to go through the IT department, and like, especially for tools that only work on Linux or whatever.
Yeah, that's true.
Yeah. So you can get more information about these jobs that are running. Like if you click on the GDS it's like made a flow graph there, and the one that's running at the moment is the GDS one. You can click on that, and then you can get like more information about what's happening inside the action. And the first thing it's doing is installing the PDK. PDK stands for Process Design Kit, and it's basically like, you know, when you order a PCB, maybe it's not so much anymore, but like you have the design rules, the DRC, and you would, if you were doing like an RF board, you would have the stack up of the layers. And the PDK is basically a big database from the foundry, in this case Skywater Foundry in America, which is the world's first open source manufacturable PDK. And it's got all the information about how many levels there are in. So we've got like, it's 40 layers in the stack up, but it's easier to think about it as like the active silicon layer at the bottom, and then 5 metal layers, like as a multi-layer PCB to connect everything together. And the PDK's got information about that. It knows all the standard cells. It knows the DRC rules. It knows all this kind of stuff, and is like essential for doing ASIC design. So the GitHub action installs that, and then the other one, the other big thing it uses is a tool called OpenLane, which is an open source ASIC tool chain. And you put Verilog in one end, and you get the GDS files out the other end. And those GDS files are the ones that you send to the factory to get your chips made. Or in the case of Tiny Tape Out, what I do is when people submit their design, they give me the Git URL, and then I download the GDS from their repository, because after this job finishes, it commits the GDS into the repository as an artifact. And then I download the GDS block, and then I tile them all together into the big multi-design, run some tests, and then on the 5th of December, that's like my tape out deadline. That's when I send it off to eFabless to get manufactured.
Oh, so that will be a busy weekend for you.
Well, that's why I'm ending. That's why the deadline for everybody who wants to submit now is on the Friday, so that I don't have to work over the weekend.
Okay. Everything automated.
We
had a question here.
The GDS has got a green tick, so that's good.
Yeah, PNG is rendering cool. the final design. There was a question for you with, this might be explained on the website, but can you get a schematic from
form of an
HDL design from WalkWiki?
What is the question behind the question? You want to be able to see what you want to write in an HDL and then see like a schematic view. That's from Sam Ellicott. Maybe expand your question a bit, Sam. And Looney, if you click up on the top left onto the summary.
Yep.
We should see like the whole page summary now.
The pages are rendering now, and then we get. Oh, here we go. Live test. Can I click on that? Yeah. This is our first design. Okay, I didn't change anything on that. This is 3D.
Yeah, so Sam, the answer to that is no, but you can use a command called inside Yosis. There's a command called show. You can do Yosis show, and that will like render your RTL design in a graphic format. But it's really only good for designs with a few hundred cells in it, because otherwise it is just gets too overwhelming. Cool. Looney's found the 3D function. So
Yeah.
so here you've got some key commands, like I think is 1 turns off the power grid. So if you press 1 on your
Okay.
keyboard,
This is the power grid.
the top blue lines, that's providing the ground and the power to all the
Yeah,
standard
that's what
cells.
I thought. Okay. Oh, yeah, that's 2. That's 2. No, wait. This is the metal layers. Oh, no. What did I do?
I'm 10 seconds
Oh,
behind.
no. Ah,
I've
I'm
got no
lost.
idea what you've done.
I pressed 4. 4. Oh, wait. Which button was that? I'm somehow. Oh, is is this a cell that I selected? Or oh, where? Oh, here we go. Okay, I'm back. Okay, I'm back.
Yeah. So yeah, so the keys do different things. Like I think it says as well in the top right hand corner. I can't see over the chat stuff, but
Filler cells.
yeah. So anything that is empty is filled up with filler cells.
What is a filler cell? Is this like a physical thing or just for the view?
No, it's a physical thing. It's actually like a tiny capacitor. So all the unused space gets turned into a capacitor, basically.
Something is missing in the display. I don't know what's.
So-
Everything
so
has a check
what-
mark here.
1 on the keyboard is turn on and off all the fill cells. 2 on the keyboard is turn on and off all the power distribution network. And
I can't move.
3 is isolate a single selected cell.
Here we go. Right mouse button. Okay. Here we go. So you were talking about metal layers. So these are like the lines here, the horizontal and vertical. These are most probably the metal layers, and these are like the wiring. And underneath of that, we have like the silicon.
Yeah, that's right at the bottom. Yeah.
Okay.
So maybe if you pick one cell, so if you highlight one cell, so it goes 3, so it's green, and
3.
then press 3.
Okay.
That will isolate a single cell.
Oh, okay, cool. So this is basically some kind of gate now.
Yeah.
Which one is it?
It says in the top left hand side which one it is selected. And then on the right hand side, you've got the list of the layers, like which is, and then you can turn them on and off.
Yeah. Okay, I can see high top cell, mouse over.
Yeah.
It doesn't. I don't know what this is. DFXTV.
And that grey blob at the back is the N well that isolates the P well, the P MOSFET transistor, and the actual silicon substrate is, you're not able to see it on this view. Yeah, so then that's the GDS is ready, and then you basically take your GitHub URL, and then you can go right down to the bottom of the Tiny Tape Out homepage and submit it.
Wait. Okay, so this is basically my tape out link. I clone that and go to the submission, which is, I go basically back. Actions, pages. Here we go. And then here, project repo.
Yeah, and it will fail because you won't be allowed to submit it until you have like the documentation action also passing, which won't be passing because you've not filled anything in there.
So okay.
Yeah, and I can give you a bunch of vouchers as like money off for anyone that is in your crew that wants to submit a design before Friday. Just let me know how best to do that. If you want to keep them for your Discord or publicize them in.
I have no clue. We can do this over Discord basically.
Okay. Yeah.
I will create a Discord channel for ASIC, and then we can
successfully infected another
Oh
Discord.
no! Yeah, and this will be basically people who want to submit a test can basically request a voucher from you. Let me check. That's main. ASIC create channel. Okay. Okay. This should be the invite link to the actual channel where you can apply, and Matt will respond with, I don't know, for the first people who want to submit a sweet test design.
Yeah.
And maybe at some point in future, in a few months,
Less than a year and a half.
less than a year and a half, I will have a board here where we can test some of the designs. That will be cool.
Yeah. So the submission process for like an HDL is really similar, but instead of in your repo putting a WACWI ID, you set that back to 0, and then you list the names of the source files and what the name of the top module is, and then you just rerun the action.
Source files.
Yeah.
Oh, so that's easy. Yeah, and
so
there is
you'll write. You can write and like prototype on an FPGA, and then once you're happy with it, you can copy the source files into the GitHub repository, commit them, push them, and then the GDS action will run again, and this time it will create it for your HDL design.
Okay, so there is a source folder already. We have cells V. That's basically already cells that we can use, like not mux and whatever. Just
that's config is like the configuration for the OpenLane tool, telling it like how big it's allowed to be and where the clock is and stuff like that. Cells.v is the translation between WACWI pictures and the standard cells we're using. And pin order is the order of the pins. Just putting it simply for you.
Okay. For the there is also the top module is like input 8-bit and output 8-bit, and that's all what we got there. Yeah. Okay.
And input 0 is your clock.
Input 0 is always the clock. Okay.
Yeah, I mean, if you're not using a clock, it's not going to make any odds. But if you are using a clock, then that's the one
we can
to use.
On the board like that we can get from you. Then with the order, we can disconnect the clock that's on the PCB. Or
yeah, you can just put your own thing in there, and like on the WACWI design, there's a little switch, so you can switch it from either the automatic clock, or you can just like press a button or toggle a switch. So, like if you watch Ben Eater's videos about like building CPUs, it goes into this in some details. Like it's really helpful to be able to single step or really slow things down. So
yeah, there is this push button, and we can switch to the push button. Like if we run simulation, we can switch that and pulse it. Okay, and set basically.
Yeah, so you could like single step through your POV design, but then when you're running it for real, you'd have it running off the clock.
Cool. And this is a 1 hertz clock here. Okay, is it? Yeah, I think it is.
Yeah, actually, one thing to remember as well is this is only the second time we've done this. It's still very much a work in progress. There's lots of places where it's kind of a bit rough around the edges, and an example of one thing where it's a bit rough around the edges is it's not easy to change that clock speed. You have to basically edit a JSON file to change it.
Oh yeah, but it's still cool for.
There's tons of stuff in the FAQ, and kind of that's basically what the Discord forum is for as well. For people like if you get stuck, then that's where you come and ask us.
Okay, cool. I
Hey, your
think
design
that's
is doing
all.
something. It's like it's spelling something out there.
What?
Look at that.
Oh yeah, you're 20 seconds behind,
Yeah,
I
at least
think.
20 seconds. Yeah.
Okay, I turned it off because it was slowing down my PC. I'm streaming like having like a Google Tcon streaming and capturing three
At least you're
windows at
not.
the
At
same time.
least you're not building the GDS and doing that remotely.
That's true. That's true. Now, I think the biggest challenge for me for submitting an ASIC design now will be to fill the document action to make that pass.
No, that's the easy bit. Just fill it. Just write to do for everything.
Okay, cool. Thanks, Matt. Is there anything you want to add? So you can. Otherwise, we will let you go home and to your wife and kids.
Yeah,
Or
that's it. I'd like to stay around for your trademark 24-hour streams, but I have to go home and eat dinner and stuff. But yeah, thanks very much for doing this. I really appreciate spreading the tiny tape out word out a bit wider. See if anyone else wants to get involved.
I mean, we had you already on. It's longer
On the
ago,
MakerCast.
like on the MakerCast, and since
Yeah.
then, this is haunting me. I mean, I just started with FPGAs, and that's like just one step further. And this is a nice baby step to doing this tiny tape out because we can like get hands on something and. You can proudly put in your CV, I designed an ASIC already.
I made my own chips. Yeah. Let me just show you my clock. This is this is one of my designs I did for MPW1.
I will try to unclick. Where's your window? Okay, here we go. And this is the first design that you submitted. Cool.
Yeah, this is from my first chip. So we've got the chip in the middle there, and then due to problems with MPW1, we had to build this extra infrastructure to work past some problems. But now I've got a nice little clock on my table.
That's so cool. That's so cool. Okay, that's great. Okay, so my goal is to put on my CV that I made an ASIC, and this is almost a cheat code to get it like the
yeah, this
easy.
Is the gateway drug, and also just if you think about it in terms of if you actually went into VLSI, very large scale integration, your first tape out might not be until you're doing a PhD, because the opportunity to do it is so low and it's expensive. And wouldn't it be better if you went into doing if you got exposed to it earlier, so you could choose if it was something that you wanted to be into, and you did your first tape out at high school? Why not? So that's kind of what we're trying to get to, is work with high schools and universities. And if you're interested in supporting us on that mission, then submit something on Friday, and that would be really great to have your design on board.
People, we will make a design today. I want to do submit persistence of vision bit shift deserializer. We will continue with that on stream right now. And if you are hooked and if you want to help build Matt with Matt JLC PCB for ASICs, then you have the chance to get your hands dirty until Friday. Get some vouchers for discounts in on Discord, and here we go. We can all put ASICs, designed an ASIC on our CVs, even though it's only shifting bits. It counts. It counts. Yeah, make a counter. Great. Okay. Thank you, Matt.
Thanks so much, Looney, and good luck with the persistence of vision. And I'll tune back in a couple of hours and see how it's going.
Okay, great. Thank you very much. See you.
Bye-bye.
Okay, peeps. Bitluni fail counter. What? Yeah, that's okay. Now I will put on TTS because TTS wasn't on so far. We will do our regular. Oops, sorry, dogs. No. Okay. Let me. Am I clipped again? So that was like, what is happening here? I don't know what. I clipped myself. Here we go. It's clipped. Is it? I don't know. Okay. Okay. I destroyed my streaming. Nobody can read the chat anymore. Okay, great. So I will turn on. I will hop on the TTS on Discord, and then we can discuss everything. I can greet you, peoples. How do I do that? Yeah, I'm confused. I'm overwhelmed. Did my internet die? Oh no, here's my lab internet. Okay, here we go. Great. Isn't that a cool thing? Putting on ASIC design on your CV. Okay, I have you. Oh no, I turn on Bluetooth now and I turn off this Bluetooth. Okay, here we go. I should be able to hear you. Okay, and now start the bitluni. Okay, where is the bitluni? Doop, 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 doop. It's me.
Yoo-hoo, it works!
Wait, what? Okay, I need to rejoin. Okay. I need to chat URL. Oh, okay. Apparently my Raspberry Pi needs a restart as well. Completely unprepared. Okay, so who? Messiler, Dutch Doris Sniff, hello Quindor, and who else? Dave Odessa, Wagon Loads, mostly Moss, Sam Ellicott, and some new people also in the stream, and everyone who will rewatch this stream because this stream is great. Okay, do we get my Node-RED running? Please reload. It's reloading. Great. Okay, here we go. Done. Okay, bitluni should be live. Hey, more peeps. Oh, I can't hear it. Is it live or is it? I don't know. I can't hear bitluni. Oh wait, I need to deploy it. Okay, here we go. That was the issue. Okay. You designed ESP. Oh, sweet. There's your coupon code. I'm completely out of. I can't hear bitluni. He's dead. Somehow I'm not able to. This should be the URL of the chat. Oh. Oh, I'm not joined. Ah, here we go. Okay, yoo-hoo, it works. Okay, great. Okay, I fixed that, and something else. Here we go. We need for this ultra long super. Where is the fondue? Oh, I finally can hear you again. We have some fondue to turn on. So who of you already did a design, an ASIC design in their lives? Who tried it before? Where's the scissors? I need scissors to open my fondue. Okay, I take this. Oh, really? Oh, I spilled this cheesy juice on my floor. Oh, really? Okay, cool. This is so exciting, people. This is so exciting. Yikes. Nothing with what? Where do I put it? Ah, cheese, a stinky cheese bag. Yeah, I have some pickles to for more accidents. Okay, this will be. I turn it on. We will give it. Okay, so what I wasn't able to listen to you before. Where's my schnapps? My schnapps is gone. Analog space. Okay, here we go. We have a small pickle juice accident here. This is Oh, really? Okay. So, I pitch you now my project while you trying to pitch me different projects. So if you want to see something else than what I pitch, then because I'm almost like, oh, this is quite hot already. Need to be careful. Doesn't burn too fast. Pink LEDs. Okay, we can do this with the pink LEDs. So here is the screen share. How do you control the phone? I mean, theoretically, the IC that I will design now, or the circuit, will basically be able to control the fondue hot plate as well. Okay, we can. Come on. Okay. Let me show you what I had in mind. Just. That sounds also interesting. Okay, screen capture. Oh, we have screen capture here. Do we have like, oh, sweet. Oh, no, that misses the fondue. Here we go. Option 22 is the name of our project. Okay, here we go. So, we have some limitations, or our interface. Let's say interface interface Pink Floyd on the keyboard. What? No. Is there a keyboard? Oh, there's a keyboard behind me. Okay. Yeah. This is option 22. Option 22. Okay. Beeps. This will be the best. Okay. Our interface is, let's say it might be like 20 kilohertz or less, but let's assume it's only 10 kilohertz maximum, like I/O, and then we have 8-bit in, 8-bit in, and 8-bit, I don't have snacks with me today, 8-bit out. So, if you want to work with like some clocked logic, with like D flip-flops and so on, and you don't generate your own clock, apparently, which you could with the oscillators within your ASIC. Which one is reset? Which one is reset? Okay, so input, we can do like we need like the clock. So we have C. Okay. Then we have, which one is reset? Yeah, is there a designated reset? So the first one, so the 0, this is bit 0, is clock. It could be bit 0. If we use only like logic gates that do nothing. Oh, okay, which one is it? Oh, that's okay. I need to check the specs. Which one, where the reset is wired? You see now. Okay, clock. There is a reset. I don't know which pin is it on. Reset. Is there a specific pin for the reset? Okay, and let's say we need like, if we need like proper things like clock reset. No, what he said, we can use also. So we can basically, if you look at, where is it? Let me check that out. So if you look at the design here, so what the board will provide is the possibility to basically use, yeah, you have like, you can use like switches to control it, or like the button or the clock. You can switch basically between those if you want to. This is the breakout board. So this is the input, and there is no designated reset as I see it now. If you want a reset, you can basically assign it to one of the eight pins. But basically, yeah, there's nothing. Yeah, but there's a switch. You can basically, you have a PMOD connector, where's this image? I wanted to show you the actual designed PCB for that. There was like the prototype for that's the data sheet. No, that's the tiny tape out too. Maybe it was only. Oh, thank you, Henrik. What? Yeah, but you have PMODs for all the bits, like here as well. See here. Oh, no. What is the sad smiley? Oh no. Okay. So where's this? I mean I was able to maybe it was on the video on it. Here.
And remember that one of the cool things about this.
Okay, here you go. So this is how it looks like, the board. Oops, let me shift that. Oops. Okay, the resulting the board. I mean, you can put it on anything that you like at the end. You get the IC if you want to. And what this board here is the ASIC, and it will basically has the dip switches to select, I think, one of the adjustable clock single step, dip for design select, 9 dips, and 8 for input, and 8 LEDs for output, and you have like the PMOD connectors here. So this will be basically input and output, I guess. Yeah. PMOD headers for IOs. Yeah, there it is. So this is how it looks like. I mean, this is how you'll be able to play around. This. No worries, Circuit IO. Thank you, Henrik. Okay, let's check out. Let's check out what. Okay. Do you have a design there? Okay, so the fun part is you can basically select other designs as well. You can select yours. We'll get. Hey Ray. So. Hey Ray. So you can select your design or different designs. And what I want. Okay. Somehow the Discord gets stuck. I mean, it's so unreliable now. Discord crashed like 5 times yesterday when I was hanging out with your peeps. Oh wow, I got a bad connection right now with Discord. It only stutters, if anything. Okay, great. Yeah, you probably have to recompile the kernel and bitluni. Okay, so my plan would be like to to get at the end the board, and a few of our ASICs that we can make a persistence of vision board. Okay, here we go. So this is optional. Doesn't have to be clock or whatever. This is all optional, and then whatever you have to fill up the it's 2 to 7. Okay. Okay, so we have output, 8-bit output, and we want to use this. Imagine we have LEDs. Do we have? Okay, let me take LEDs here. This is the shitty color. Yeah, Maya, I'm doing the tiny type out. This is the pitch for the project. Since you people didn't bring anything to the table today to suggest, I thought of something. If we have 8 outputs, we can basically address. Okay. We can use 8 LEDs. This will be our out. And then put this basically, we I don't know, our ASIC. This will be our ASIC. A battery. We can use a slip ring with, let's say, 4 wires or whatever. We only need 4 bits input, or in reality we only need 3 bits input. Okay. Yeah. Explain what you suggested. Wagon loads. Explain what you suggested to do. Okay, but I had like to. So we have like. Okay, we might need like also power and ground. So it might be like. Yeah, but then we have. Okay, we need power. Okay, we need like 3.3. Then we need ground. Then we need a clock out, a clock pin. Let's see, okay. Then we need a data pin. Oh, as data, or wait, data in, and we need maybe write enable or write to indicate that we want to submit something. Yeah. So what I will tell you what all these lines will do. And we will basically use some resistors in between, but whatever. This will be our bus, and it's basically blup, blup. What is what? Okay, here we go. We have the LEDs, and then look at this. We rotate it. We rotate it with a specific. Okay, this is not. It doesn't look like the rotation center. Okay, however. What we want is to put graphics on here, okay? We want the graphics. We want, let's see, like to draw a heart. like draw a heart, like that. Right. Bit. Okay, write something. And this is basically, yeah, persistence of vision. It's not a POV, it's a POV, vision with V. Okay. So we will pulse this here, which is basically a parallel output register, 8-bit parallel, and we have a clock, and every 8 clock cycles it will basically fill these here and switch them for build a tiny ray tracer. Yeah, it's a ray tracer of a persistence of vision thing. So okay, so we have a clock. So this is the input. We have a clock. Oh, this is the wrong color again. We have a clock here. This is the clock. And on positive edge of the clock, we have like certain lines. Okay. We have yeah, nothing missed here. So every 8, what it does is inside we don't have much space for much logic. Okay, but what we can do is we can put in a long buffer with many bits. Let's say this will be our buffer inside with 8 bits. Word size is 8-bit because these are our outputs, and we need to fill this buffer and we will fill this basically with the bits that we need, like to draw let's say bit. Okay, so bit will be like that. Here this is bit, and so now now we need only to like shift this in, which we will do with the clock. And we can basically cycle through all this buffer with the clock, and whenever the idea is now, so we have the data in. This is our data in, whatever we want to write there, whatever. And here, this is the write bit. And basically, whenever a write bit is high and we get a clock here, a positive clock edge, this data will be basic. Oh, this is a bad example. This bit will be written as 1 in the on the actual the current position of. Okay, so this is basically what happens. A high bit will be written on position number 0. Okay, here. So this happens here, and then next positive edge, yeah, it writes, it shifts by 1 on the positive edge and then writes the thing. And the output will be always like the first word, but it will be only copied because you're shifting like 1, 2, 3, 8. You're always shifting the complete buffer. It will basically push the bits like around here, around there, and the last bit will basically move up to the front. Oops, up to the front. And if write is high, this is our write. Right, this is a D in. If write is high, the first bit will be overwritten, otherwise it will be the last bit from our buffer. And yeah, we have a counter which counts to 8, so 3-bit counter. So 8 is basically, if this is like clear, then we will set the output. This is the out. This is the idea. Every time we rotated, we shifted 8 bits, it will read the byte, the current byte, and put it to the output. So we won't be seeing on the output here, it's basically a deserializer, because you can write in the buffer, shift it away, and output it again as a parallel byte. Cheese is burning, no? It's almost ready. Very, very simple design. Whenever this counter is 0, I hope that doesn't like take a lot of gates to add 1 to a 3-bit thing. It might be even like simplified to a few gates at the end or whatever. I hope the optimizer does a great job. Whenever this is 0, this happens, okay? So the output will be set. Yeah. No, it's not done yet. I want to destroy his kitchen when it's completely done and when he feels safe. Okay, so that's the plan. Making a persistence of vision, but you can use it for anything else. Like imagine that you can push something in and output it again. It just rotates like 250. Yeah, it's a shift register, but it has like 64 bytes or something. Yeah, it's a shift register, deserializing shift register. Wait, no, it's a shift register, but like with extra memory. And as long as you're not overwriting it, you can store stuff there. Might be even It's always clocked out. Yeah, that's something I rather set up the DC motor to rotate at the right speed, so we can spin it right, left, whatever, and adjust the clock speed, because we can't be sure right now what clock we are able to do. So I will keep it to the simple design, which is basically a super long shift register that every clock cycle it will shift the whole register, rotate by 1 bit, and every 8 bits it will stage the first byte of the buffer. So it will basically, every 8 clocks, it will output a byte, and it will be able to store, I hope, 64 bytes, maybe 32 even will be enough to display something on a circle here, which should be a super easy design. And I mean, this is like meant for education, but we can actually make a functional thing. I posted a picture. Do I dock some? Oh, I have the Discord turned off. Okay, let me check. Discord messes up things here. Okay. Oh yeah, that's actually propeller LED clock. Yeah, that could be one of the use cases. But you can display anything there. You can do a Tetris rotational. Ash, not yet, but yeah, you missed basically how we already implemented this beauty here. So it's not like it doesn't meet the requirements yet because it has like different inputs, but I wanted to test it on an FPGA. I show it here. I have the GoWin whatever super duper FPGA, which has PMOD connectors. All LEDs are lit. I don't know why. What did I program here? Oh no. Did I break it? What did I do? My design doesn't work, obviously, yet. But, oh wait, you can't see anything. Yeah. Yeah, that's really cool. So we can basically upload like a top file, which we don't need the input clock anymore. Which is cool, okay? We do that. Here's basically our inputs. Reset, write, bit, show. Show is something that I wanted to use for displaying the current state, which we can remove from the final design. It's not needed. Yeah, that's not user friendly. If VHDL is so mean. I heard it. You need to match the bit count and so on. Okay, so we have an input. This is our top module. Verilog. You don't need to be like proficient in Verilog because I'm not either. but it compiled so far, which doesn't mean anything. But we can route, we have like inputs and outputs. This is already a good definition here. We have design files. Okay, the clock doesn't happen anymore. So clock isn't there. We haven't specified input here. It will probably complain now about an unspecified input. Can we input ground? We can just take different IOs here. This is not really important. T6, 7, 8. Okay. Input. These are basically buttons on the board that I'm using. So everything is labeled on the back, and we have like, unfortunately, only 5 buttons. I don't have a board with 8 buttons, which would be nicer. A PMOD board with 8 buttons. Okay, but we can add 5, 6, and 7, and we will route it to T6, 7, 8, 9, T6, 8, T6, T7, T8, which are on a different. So these are like digital digital write ground high. That's a nerdy joke. Yeah, that's basically what will happen if I define like 2 lines here. Okay, this is PMOD. And these are buttons. Okay, PMOD buttons, and we have, we define what kind of I/O levels we get there. 5, 6, 7, one job. Okay, here we go. And this is the PMOD where I have my, basically my LEDs attached. I tested this already. Okay, top module and clock 2. Okay, first input line is our clock. Then we have a reset, which basically resets the counter. Otherwise, I mean, you don't actually need a reset, because you could basically clock in. You have you can't like delete. That would be so much gates if you want to delete every D flip-flop in our buffer at once. Can't do that. We need to clock in zeros, which will be basically, oh yeah, resetting is important. Now I know why. Because the counter will only clock out every 8. Yeah. To what? Hey, Peter. Okay, clock, reset, write, bit, and show is our debug stuff. From something other. Yeah. since like the writing stage will be only 1 bit now. If we had like 9 bits, like clock and 8 bits, that would be awesome, because then you can do more, like using one clock to set up the mode and then clocking in complete bytes. That would be nice. Unfortunately, we don't have clock and 8 bytes, and I don't want to split in nibbles. That will be like odd. We just yeah, that's true. So we need a reset, but we don't need. Do we need the reset in the slip ring? I don't know. But unfortunately, all the P modes are designed to have only 8 lines. Splitting, what? Oh. Okay. So now we have the clock. So we will do our things on positive clock edge, which is basically our first input, okay? Then we have a counter. Okay, so maybe I explain everything. I set like a parameter word count 64. And the buffer is a register with the word count times 8 minus 1, which basically 8 bits per word. These are all the bits, okay? And we have one register for count, because we need to know on what position of our shifting we currently are. Static clock changes. It's not a static display. It's like, it's, oh, it's moving the wrong direction, peeps. So the clock basically shifts out byte by byte the complete buffer. It will rotate, so everything will repeat. And we can set the clock and basically the RPMs of our POV. We can set it so we get the complete circle with our complete buffer. Okay, so we basically assign the wires. Yeah, it looks like Pascal, but it's Verilog. So this is a hardware description language, apparently. It isn't sequential. It's like everything happens at once. This is basically like wires and gates. There are some logic levels and some. It's hard for me to explain since I'm such a noob in this these things. However, I still can submit an ASIC. If that works on a FPGA, then it will also work as an ASIC, I hope. Verilog. Yeah. Sniff. A-team. David Watts is triggered by that. Okay, here we go. I implemented this. Whenever we reset, would you need just one shift or use one shift? You mean this? What? Okay, we beautify it for you. Okay, so this is reset. Whenever reset on the clock is reset is high, so it's not like not reset. It's like reset means we reset things. Yeah, it works without. Apparently, it compiled. Yeah, it compiles without the spaces here. Sick, isn't it? Okay, let's compile and see what the output is. Oh. Yeah. Oh, we didn't save it. Yeah, that's an oddity of this IDE. It won't save automatically. Okay, basically it compiled already. So this is our design. And we can upload. Here we go. So resets the counter and does nothing else. This basically resets the counter because otherwise you will be resetting the counter and it might like wait a minute. Do we need to reset the counter? Async, sync reset. I have no clue. Messiah, where is Ash when we need him? Someone call Electron Ash. Okay. Ash is here. No worries. Okay. So we have the non-blocking and non-blocking assignments. Asynchronous reset. Yeah. Can we do like or a reset and do an asynchronous so we won't be needing a clock for that? Otherwise it's not really in a clocked always block. Why? I mean, it will be. Oh no, it's. Oh. Look, if that works, we don't need to clock anything. The extra begin here. But what happens, like how do you assign What happens if someone uses clock and reset at the same time? I mean, if we have it like that, okay, removing that, yeah, we can remove the begin, but let's keep it. Especially if we control the clock. It doesn't matter. Whenever reset, it doesn't do anything. But we need to think about what happens when we reset it, okay? So when we reset it, the counter's at 0. This will be like the highest bit first, MSB first, or lowest. Does it really matter? We can. Yeah, that's true. Okay, and you said we use like this is the non-blocking. Yeah, that's true. Non-blocking. But what does the non-blocking mean again? What does the non-blocking mean again? Ah. But we save gates if we set it at the clock edge, okay, but that will basically generate a new D flip-flop. We won't just you know what? Okay. We can see what the result is from the hierarchy, okay? Let me just wait. Where's my I can see anything here. I want to see the gate count. Yeah, okay. So, oh, right, okay. Ah, yeah, update. Okay, here we go. Oh no! It used LAU. Loots and registers. Okay, blocking kinds waits for the result from the first say you're doing. Okay, yeah. So this is like sequential logic. Okay, let's do that. Non-blocking for everything here. Okay, cool. But we need to like change the count So when the clock edge appears, okay, yeah, that's what they tell you, but yeah, you're right. We want to clock everything, but we want to save gates as well, if possible. Okay, this is the case where we oh, yes, Sniff, yes, you could. You just take the code, the tiny tape out example, which is basically simple Verilog, and use that. It's funny because you shift in, I think it's 4 bits each, all the wiring and the lookup tables, which is crazy. And then you have like a flip-flop and a lookup table per cell. That sounds like a video idea. How many FPGAs can you? Okay. What happens next? Now we need to see on this clock, when do we shift? We have to do it sequentially. We need to write something or shift and then write. What do we do? Write and shift. Okay, show is something else. Don't. We can do it like that. We can always show not the register contents. Or should we? No, just. Yeah. I will do that. So this should be not timed. And if and. But it's. The output register is already a register, so. Yep. Okay, update. I have no clue. It removed everything. Oh yeah, because it optimized away our buffer that's not doing anything anymore. But let me program that to see if we are even doing anything right now. Okay, let's program that. Oh, this. Yeah. Okay. I have the impression this will be a long stream. Yeah, let me. Okay, we have now. Did it upload already? Is it done? Oh, is it reset? No. Why is it showing all LEDs? Is reset always positive? No, it's positive edge. Yeah, it's a certain functionality. We will do a POV. Did you miss the drawing? So it's a long buffer that basically displays eight bit columns. Active low. Yeah, but my reset, oh, I don't know what the button is. Okay, let me okay. Oh no. Wait, what? Why should it be on the sensitivity list? Oh yeah, it's on the yeah, let's remove that. Yeah, clock signal, that's just a warning that our okay, now let's upload this and then we should see the buttons basically shown. Oh, is it blocking? Oh yeah, you're right. Let's do that. We should be able to see the clock and the button states. Oh, what is it doing now? Oh yeah, it's programming. I could see the programming. Okay, I need a camera for you. I will set up a camera. I hope I'll be able to set it up here. Doop-a-doop-a-doop. What? Oh yeah, no, it is a one. A decimal one is 001. What? Why are you doing that? You should use then B00. Yeah, it is. Okay. Why? Why is it doing that? Why is it? What is? Okay. Let me get you the best view possible of the FPGA. Yeah. Ah, that's a nice picture. Choo. That's let me make this. Why is it like 5 kilometers big? What happened? What is this? How do I fit this to the... Yeah, people will hate the stream. It's not very condensed. Yeah, it's so confused. How big is this? Control plus F. Here we go. Okay, here we go. So why is it doing that? I don't see anything working here. It's not working. Out. Yeah. We saw like this upper corner here, the upper corner of the image. No, because we don't, the clock. Oh, wait, it did something. This is the button is CLK2. It might be bouncing, but you know what? We should basically do in sensitivity list now, because otherwise we won't see anything happening. Okay, let me push the second button and clock. Oh yes, okay, that worked. And why is count not counting up? I don't see. Kinda working. Okay, so clock, and it's displaying the count on the first 3 LEDs. And then it's input, but input 0 is the clock, and this will be always high. So we can we just do 0 here. Yeah, test bench. Oops. No. Yeah. We always seeing like the positive edge, but why doesn't it? Okay, we can see the buttons, but I want to see the clock. The clock doesn't increment. The count, I mean. So the incrementation doesn't work somehow. Whenever I press, it's sometimes like the. I never see the first ones. How the count defined? Count is a register. Oh, it's 4 bits. Oh, it should be only. Okay. It should be only 2. That's the button. It's in 0, which is the button. Let me upload it. I should try out the SRAM upload. Okay, it's ready. It doesn't count. Why doesn't it count? When I press the button, it should be counting. Yeah, but if it would end at a different count. Ouch. Oh no. Jeez. Yes, it is. No, everything is all right with the dip switches. I can show it to you. So if we basically, oh no, we can't remove that because I have comments here. How would you be incrementing a counter? Is it correct? It should be correct. Or do we wait? D0 is the top LED. This is, oh, the counter is on the top 3. Yeah. Okay, if you mean so. Okay. Yeah, but also I can show this to you. Yes, count stuck on 4. Three bits. Oh wait, yeah, that makes sense if count is. But now count should be 2 bits. Did we do it? No, it. Can you set one of the LEDs to be clock outside? Yes. That's a good idea. I will. No, I don't know. Maybe it is a assign output. Where's a concurrent? Do we have a concurrent assignment? There is no concurrent assignment. Where is no concurrent assignment? Yeah, our tree is gone. No. Okay, let's do it like, you know what? Let's do it like that. Okay, let's do y. Oh wait, we have at CLK. Yeah. Yeah, it is. It is. It is. That's the. Okay. Always. Yeah, what about CLK? Okay, here. CLK2. Okay, that works. Okay. What? Programmer. Let's change the. I don't want to flash every time. SRAM mode. Let's try. Oh no, how do I bypass SRAM? Does it work with SRAM? We might be faster with using only SRAM programming mode instead of. Yeah, but now we need to be. Oh, okay. Yeah. Ah, look at that. The focus is not on this part here. Okay, here we go. Okay, here we go. This is your button. Ah! Maybe we should put. Oh, we can do that because it's concurrent assignment. Is it concurrent assignment? No. Can we do this? Okay, let me check. It's a game. It's a game. Okay. We can basically use everything like that, like the output. I was stupid not to order more of those things. What? Okay, wait. Let's program again. Loop. I mean, debugging super simple stuff will take us longer than generating the resulting Mr. Fork. I need more cheese. FPGA is more difficult than ASIC. Interesting, look at that. A simulation would be faster. Okay. Adam. But these are cheap. Butter stick? What? Okay, let's do a test bench. Okay. Test bench is a Verilog file, isn't it? How do I create a test bench? I have no problems. I need to... That's cool. Butterstick FPGA. Who made this? Okay, this is basically top, test bench. Okay, here we go, test bench. And time scale. Scale will be 1ns. Module top TB and okay, and module. Then we have top top blah, and then what? In, out, wire out, oops, 70, whoopala, rack and then initial oh very later. Let's keep it written out, otherwise I won't know anymore. Okay, we can do it like this. So I know what's meant by that. Really? Otherwise, that's true. If you're not able like to deploy easily, then huh? Then why do I need the dots? I don't need the dots. Huh? Why? What are you? Dot star. What? Huh? Yeah, I don't. Okay, let's keep it. What do I need? Initial begin. Oh wait, here. Yeah, you're right. Otherwise it. Oh no. Yeah, it says and module, but what the? What is? I tried. Syntax error. Root scope decoration is not allowed. Okay. What is one error? What is wrong with that? I mean, top test bench. I will try. Module test bench. Here we go. This is our test bench. Oh, we can switch to a system Verilog. I don't care. What? Oh, it's, oh no. Din. Okay, let's switch that. Yeah. Okay, so, and how does it help me with it? How does your fancy system vary? No. Okay. What is wrong with that? Physical timing constraints logic. Yeah, but it also works like that. The order is the same. Please give me like... Ah. How do I change file properties to be a test bench? Is there like maybe a process timing constraint? Yeah, it most probably does. Timing constraint. Synthesize first. Okay. 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 It's done. How do I simulate here? We have like view help. Oh no. Okay, we wasted time on the simulation part. Okay, my dudes, I don't know how to set up a test bench. If anyone can find any example of a test bench in GoWin, then please poke me. Otherwise, we can use a different tool for that. Okay, I want to. Okay, let's try something else. Let's try that. Oh. It's very, very, oh, no battery remains, okay. Yeah, I could use this if we can find a way to, I mean, only that I'm not familiar with how to run a test bench from, but there should be a test bench somewhere in like an example project. Yeah. What did I want? I wanted to upload. Okay, I think I'm done with fondue for now. Let me just put the lid on because that really stinks. Ah! Did it upload? Yeah, all bits are set now. All bits are set. I lost my power. Yeah, I will open the door so I get some fresh air. And where's my power supply for the... Okay, here. Here it is. Okay, here we go. Okay. Is this, I hope, who is pinging me? I hope it's a test bench. Oh, okay. Yeah. I will pin the coupon code. Pin it from Matt so we don't like drown it in messages. Here we go. You see anything? Not yet. Okay. Now it's rotating, but it's always on, so we should... How do we set it? It's stupid. There is no reset. Okay, let's do it like that. So Yosis it is. Who has Yosis installed? Yeah, that's unfortunate. Okay, let's do... I mean, it shouldn't be difficult to like... Let's keep focused. Einschaltungszeit. Hey Dave. Member meeting as always. Oh yeah, that could be. Yeah, Quartus. What is Quartus? Did we program it already? Okay. Yeah. Okay, Messala, I got you. You give me Quartus then. You're probably not paying attention. Oh yeah, you're right. I had it hacked out. Sorry. Really? That's the best. Can I use Quartus now? Here we go. Oh, there is no... I need to clock in the reset then. Count is doing nothing. Okay, you know what? Input clock. We have no clock constraints or whatever. Let's use clock first. Clock and then always synchronizer. Oh yeah, I didn't program it in. Yeah, it could be. Yeah, but it doesn't do anything. Even if with the external clock, it should move around like the bits or whatever. Okay, let's make it an adder again, like that. Okay. This is okay. This and the clock divider. Okay, let's do clock divider. Let's do that. Always add edge CLK. Who writes something? Diff, yeah. Yeah, that's a clock divider. Okay, yeah, thanks. That's what I just wanted to implement. Here we go. That's our clock divider. What is clock tick? Okay. CLK2, and that should be that. Let's check. Yeah. And now it should be flickering lights. If not, I'm disappointed. Wait a minute. What is? Oh, this is reset. Okay, it's pull down. Oh, okay. Buttons are pulled down. So neck edge reset. Oops. And we need a different divider, my friends. Let's do 32. Oh wait, this will be 27 megs. That's no, not 31. Let's do that. 32 bits will be like way too slow. 1,000 seconds. Yeah. 2416 million, which will be okay. That's fine. We have 27. That's like half a second clock speed. Okay, here we go. My friends, here we go. Moment of truth. Yeah, that's inverted, huh? Yeah. LEDs are also inverted. You kidding me? Oh no. Okay, let's do like, oh no, this is right because no, count and the buttons are okay because they are inverted as well. Okay, here we go. Okay, counter works now. But how do I test it with that clock? Okay, let's get back to our manual clock, and then you want to buffer it in. So let's do rec C1, C2. How do you do that? Assign C1, C1, C. Oh yeah, that's wires only, huh? Okay, let's do this like that. We will use a buffered input. So red. Where's my wire? It's gone. It's gone. Okay. Let's try with one register first. Okay. Does that work? Oh, did I deactivate like the divider? Where's the divider? Oh. How do you do the debounce? Every clock cycle then. Oh, okay. Give me the code. Give me the code. Okay, let's do it then. Rec CB Okay, let's do it like 31 times. Oh yeah, that could be also right. You're right. We can use another bit here. No, but then if we had like we set the timeout. This is a frustrating stream to watch. Yeah, because we get stuck at such simple things right now. Okay, yeah. In 0. Wait, first of all, we need CB equals in 0 and CB Now let's do it like that. CB Oh, that's wrong. 1 and 31. Okay, like that. And CLK2 is basically and CB. Is this right? Is this your buffer? Such a bad code. What are you talking about? My code is perfect. People are complaining today. I'm so polprzewodnikowy. Do you see that? Do you see that? Unfortunately, somehow, wait. Hä? 0, 2, almost. Yeah. Okay. We can clock in. Okay. No, it's not. Here we go. And we make it like, oh, hell yeah, we make it this. This is fancy. We make a super bouncy. This will be bounce proof deluxe. Okay? Bounce proof deluxe. I call it the bounce proof deluxe. We could make an ASIC design for this bounce proof deluxe. Look at this. I printed this with squishy filament. It's not very squishy, but it's squishy. No, it isn't. It's not. There is one. What are you talking about? Oh, you don't see that. Nah. Okay, here we go. Perfect! Now we got it. SDC file. Okay, here we go. Clock constraint added. However, look at this. This is our counter, which works perfectly fine. Cool. This is cool. Nice. Okay. Now we can clock in the bits. Cool. Okay. I need to edit the stream and maybe just cut away huge chunks of the stalling during this dreadful process. Okay, so this is our debug output, but wait! I have more LEDs here that I can use for the debug output. I will just do that. How about that? C138. Yeah, but you didn't offer solutions. You just mentioned the debounce thing. Streams for 10 seconds video. You have a short attention span. Okay, let's do output. Put rec, and we have basically how many outputs? Cats in Ukraine. We go six bits, so it's 5, 0. Outstanding. Thank you, Dave. You are very supportive of my endeavors. Yeah, compressed. Okay, here we go. Oh, thanks, Max. Bounce proof deluxe. Yeah, unfortunately, that won't be enough to book one. Bounce proof deluxe. Okay. Yeah, that's like okay, let's do it like that. We will see the shifting bits, okay? This is Wait, why didn't I? I just do this. Does this work? Is this all right? Yeah, haha. When do we wait? Shouldn't we do it like that? Right buffer, push, count. No, it points at the first. At the last, no, that's all right, D0. It just needs to be this order, but we need, oh yeah. Okay, yeah, but this, I do it like that. Buffer. Okay, wait. Yeah, we don't need the divider any. Oh, we might need the clock divider later. Yeah, I see that. This is debug. So this will be debug. Counter, clock, reset. Okay, so these are our debugs, and we need to do that. Unfortunately, I don't know. Somehow it's like, okay, what do we have? C13. Yeah, it's I think I have a responsibility to all the noobs like myself who are watching my stuff for it to be readable. Otherwise, we will all end up. What is that? N16. Yeah. No, Polish notation is when the operator comes first. That has nothing to do with that. Please don't confuse. L14, L14, L16. Yeah, there is. Oh shit. Even more of that stuff here. Can I define it like an array for all of the debugs? I like curly braces in new line because I want to see if you have like IDE I want this ending curling braces to be in line with the opening ones. That's just by personal preference. Pop, pop, pop. Okay. But now you switch to same line. Huh. Hä? New token. Okay. As long this doesn't work, I will comment it out if anyone don't know what the error there is. Yes, it did. Oh wait, is this done and ready? Oh, yeah. Wait. Ah, that was basically what we had in chat before. Yeah. I don't know what the problem is here. I don't know. Okay. I mean, it worked without, so let's not. Okay, it complains that the two LEDs are. Foo! Maybe I can use ready and. Yeah. The junk. Dual use. Okay. I had to do this to use both. Clearly not. I love it. Okay. I make an ASIC live. Okay, here we go. Wait, we didn't upload yet. Okay. I want to be friends with the person that wrote the going thing. Oh, okay, this is our counter. You can see. Okay, so we have our debug output. The contents here are basically random. Okay, what is the data input? Okay, let's try to input some alternating pins. The problem is we see only. No, it's the option 22 ASIC, the best one ever. That should be added to the shift register line. Okay, which one is in? Which one is in? Data in write. Okay, if write, yes, it's supposed to be. Reset is first. Why didn't you see neg H? Reset is the second. Why didn't it always resets? We need to clock in the reset. Why is it? It seems after the reset it's incremented. Oh wait, we assigned it. It got a 1 assigned. Okay, it was my fault. Okay. I fixed that. That was from debugging before. Okay, reset should be fine. And we should be able. Oh, you're fun. Okay, here we go. I don't believe you people. Yeah, no worries. Okay, here we go. Okay, our clock. Let's see if it worky, okay? So clock increments, this is 0. Then we have reset, which basically resets everything. Reset, 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 reset. Perfect. Okay, reset works. Now we have, okay, we shift stuff. Let's shift in some ones, okay, shall we? So we need to press right and then clock in 1, 2, 3. Oh, okay. We shifted in only 2. Okay, let's reset. We need to start from 0. Okay, right, since we have. Wait a minute. 1, 2, 1, 2, 1, 2, 1. Done. What? Why doesn't it show? Oh, now it shows. Okay, wait. Okay, I know what happened. I know what happened now. What happened now is that we have the addition and the comparison. Oh, you don't see. No, it's neck edge. The reset is fine. Okay, let me remove this. The problem is that it assigns No, that will be too early. Let me remove that. So it's hard to get what. Uh, on this one we have like 20,000. One of the main issues of this design is in front of the computer. No, it's not anymore. I mean, we have a separate clock which clocks the other stuff. $20K blocks with some loots. We have alus, we have everything. Okay. Wait, are we inverting the buttons? Show is gone. We don't need show. Neck edge is not bad. Yeah. What is that? Timing problems. Ledges inferred for net. Ledge inferred for. Okay. Yeah. Can we change that to D flip flops? Oh, really? What the F did happen right now? I changed everything, now nothing works anymore. Huh? Unlatch it. Right. Yeah. Ah. Schematic. Let me check that. 1050 register. It seems to use like, okay. Usually, I don't know. Supply information. Net lists, floor planner. Yeah, I can. How do I find anything here? Ports. Tools, schematic viewer. What is that? What do we do here? Nets. Yeah, someone wrote it on a weekend, I heard. What is a white D flip-flop? What is D flip-flops? I don't know what that all that stuff means here right now. Okay, I don't know what you try to find out right now. Primitive sports modules, clock. 2 weekends. Yeah, I want, if you are able to do something like that in 2 weekends, I want to hire you. I will build a company around you, like you will be just coding, and I will be selling the codes to other companies for a lot of money, and I give you also a bunch of money for that. I'm satisfied with a small margin. Okay. Did we upload already? I don't know what we did here. I'm distracted with stuff again. Yeah. Didn't he? Okay, here we go. Reset works again. Clock works again as well. Okay. Now want to see write. This is reset, this is write to shift in bits. Okay, we are shifting in bits, but it's like one step behind somehow. Oh, this is hard, right? Because I need to. Oh. Do we negate the output because the bits are inverted now? I bet when we commit our design, everything will be inverted some. Yeah, that's no worries. Okay. Because we have the buttons inverted and the outputs inverted. We should really wrap around this, because this is we will clean the code up, okay? We will clean it up. You have just have an even amount of mirroring to be okay, huh? Okay, clocking in. Let's test the functionality here. Let's test the functionality. Okay, if I clock, it rotates when I... Interesting. Why is the first one not set? Doesn't do anything. Oh, this is basically the knot. It could be the knot. What does the knot do? Is this right? Does the knot invert everything? Because now it looks like it's not properly knotted. Knotted. Or should we clean it up right now? Netted. Okay. Only 1 hour left, and no, not November is over. Oh yeah, you're right. Tilde. Inversion. You're right. Here we go. Okay. And then we will do... Yeah, that's true. Okay. Now the fun part will be, we will make a module which will be the actual module, and the top module will have all this clock shit and everything. Not tilde, it was the Dach. I don't know. Caret. Okay, caret, it's the caret. A carrot. Okay, now we will do the module. Was it? Option 22. That's our module name. And input 7 0 rec Okay, this is our oops, and module. Okay, now, oh, I wanted to upload it. Did I upload it already? No, I didn't. Huh? Okay, here we go. And module, and now we can do all this stuff, but do it right. Okay, ASIC uploaded. Let's try. Let's try if we can. Okay, clock works. Writing bits doesn't work. It seems like only the first bit is changing. Okay. What? What? What sound? What do you mean? What sound? Okay, let's move everything up there. This is our real module now. What ping? Oh, wait. Desktop audio is on or what? Oh, I'm sorry. Oh no. That shouldn't be on. Okay. I turned it off, sorry. For some reason. Yeah. Desktop audio was on. Yeah, no, you don't hear it anymore. I'm sorry. That was. Let me just move everything up here. Buffer count, write, reset. Oh, sorry. Okay, and this is now the top module, which will basically POV we don't need anything here. Which is basically does that work? Oh, but how does our debug work? Oh no, we break our debug. Oh no, let's ignore everything what I did up there. We don't have our debug output. Oh shit. Oh, come on, don't be so grumpy. Good night. Yeah, let me remove that again. Oh yeah, you're right. And yeah, thanks. The other one was XOR. Okay, here we go. So, uh-oh. Yeah, tilde. That's that. I'm lost. I don't know what I did. End module. Oh, we have two end modules. Okay, here we go. Okay, let's see. If our shift. Okay, this works. Why is the output? Oh yeah. Huh? Yeah, it's delayed. Okay, it's delayed. We said right, this is reset, this is right, and this is, so we set it. But it arrives one later. Okay, when I set it, it should arrive instantly, not the next clock. The display is one behind. Did I do something wrong here? Why is it always one count behind? Okay, it assigns the buffer. Yeah. But that has to do, like, I mean, this has to do with that here. If we tried a blocking, then let me try something. Let me put this. Oh. Let me do that. Yeah, but if we have only one clock, so what we want to do. Oh, wait, what? You know what? Writing the bit could be async. But we might want to clock in the bit like really fast. It would be nice if we can clock in the bit. We can clock. Wait a minute. It's async. Whenever this is high, it should overwrite the first bit, which it does right now. Should it also overwrite it? Yeah, but we can't do it on the post clock edge and on the buffer, on the shift. Okay, let me check the... Okay, what is this? What is this? You either explain now. I can't read, like, because everyone else will be bored if I read like half an hour. But it doesn't matter if it's active high or low, does it? Oh no. Oh no. We forgot that. That might be like... Because otherwise the positive clock edge, but if we clock on like release or not release, it doesn't matter. Okay, now we should be seeing okay, here we go. Okay, clock is still working. Clock is still working. Nice. Okay. Now, if we want to write, we can overwrite everything, which is happening now. And then we can press Okay, now it's not delayed, the output. So the problem is having like the output and the shift in the same on the same clock. So having the output right here, right after but the inversion doesn't matter really. It's like, so we can clock in like a 1. Oh wait, clock, 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 clock. Okay, this is cool. Okay, I can clock in now everything, and now the interesting part. Yeah, the problem is now that we need it like, we need it not here. This is debug. This is only debug and debounce and generating clock. So this block won't exist anymore. The output needs to be yeah, no, this is what I initially wanted, okay? So this is what I really wanted here, not that. How do I okay, I have an idea. Okay, this is how it works. Wait a second. Wait a second. 6. I will show you what will happen. So this will happen later. Clock count. Yeah, that's what I have here. That's what I'm doing here, but this needs also to have the count updated before that, and since everything is happening at once, this needs to be count 1 because this is clocked after that. So the adder happens later, and this is din, and this is basically, oh shit, din and the last bit. Yeah. 7, 1. Oh no, out, yeah. I think I got this, because these are non-blocking. No, everything happens at once. So nothing is shifted yet. So we need to take the first 7 bits and the new one also to the output, which is done here. So now that should work, and it should also push, like stage the output only on after the last bit is set. And I hope that works. I show you how that works in a second. And I think we are finished. We just need to clean this up and then we're good. Okay, so. Okay. Did you see? It's staged the last bit. So, we write a 1, then we write a 0, one more 0, a 1, a 0, and no. Wait. Okay, let's start with 1 bit. Boop. Now we are 1 behind. Ah, fool. Bloop. No, it's the first. It's the last one. Oh. Oh yeah, we are shifting up. Highest significant first. Okay. Okay, that's correct. I think it might work. Okay, if I reset, it's reset, okay? I might also want to reset the output. Yeah. When we reset also the output, okay? So out will be also reset. So that's one thing that we in this case it needs to be tilted, the output, so we get, okay, I reset the counter. Now I push the highest significant bit. Then I leave a gap of 2 bits. Then I will push 3 more bits high. Then 1 bit low. And 1 bit high. Okay, here you go. 1 bit, 2 gaps, 3, 1 bit low, 1 bit high. And it showed. That's done! And now we need to push it and see if it returns again. So the persistence of vision At some point it will appear again. At some point our byte will appear again. After 64, oh man, I should have, let's make it shorter, shall we? Okay, I make it shorter. So, yeah, you got this. Okay, so we will clock in bits or not clock in bits, just shift them around. And at some point it should basically appear from the start, our bytes that we clocked in before. But it takes a while. It takes a while. We can add a logic to yeah, that's the plan. And you can yeah. Yeah, finally someone got it. Ah, yeah. That's the first byte again. That's the first byte. And we will get our, there will be one. Wait, is it the next one? On, off, off, on, off, on. That's not the one. Next byte. Here you go. It works. Oh. I built an EEPROM. No, it's like an SRAM. It doesn't stop permanently. Yeah, I could. But what is the is there a reason to shift by, like, we have like spare inputs, so we could do like shift to next byte or something, like an extra bit that can basically move to next byte for whatever reason. I don't know. Is there a need for that? Like turbo shift. Next character, next byte, or next character. Why is this so choppy? Discord is choppy, or my phone also dies. Yeah, I don't know if it's necessary. It adds logic, basically. We want to maximize our columns count, like a word count. So what we have now, it works. This is our design. 64. Why is the latency so shitty? Ultra low latency. I don't know why it's complaining. Or maybe you should. What happened? That's clock finger. Okay. Peeps, I have a working design. This is a working. Let's clean it up. Oh, this is broken. Why is this so broken? I need to leave and the audio chat because it's now like... Okay, here we go. Okay, I hope it works again. Okay, peeps, let's clean that up. I will clone everything here. Persistence of ash. Okay, here we go. I will put this in here again. I like the debug output though on the other one. We won't have debug out. Reset, write the in, count, buffer. We don't need the debounce. We don't need register CLK. We don't need that block here. We don't need that. We need that, because that's all inverted. CLK and yeah, wire CLK equals, can I equal or do I assign it? I think the one, this is like an, I think that's like a newer spec. Yeah, gotcha. Okay, I will save at least this line. Clock, word count. Okay, let's do it. Okay, and this is gone. These are the registers. Let's do the wires first and then the registers. Okay, I finally wrapped my head around this. Non-blocking and okay. Here, here, here. These are the three outputs. And the inputs are already inverted. And that's it. This is our module, option 22. Everything stinks like cheese now. Okay, people, I'm ready here for submission. Option 22. Now, I will do a backup of this file here. Let me compile it. Yeah. Yeah, multiplication. Whew. Yeah, we tested. We invert the input and output, and let's do this like top 2, and we do a top module, an actual top module that uses an instance of, okay, this is top, and we don't have a debug unfortunately in top, and we don't have that debouncer. It does the debouncing, it does the clock, not. Oh, isn't it like, don't you have like a ready library for floating point? Hey Bruxus, how are you, man? Yeah, it's been a while. What have you been up to all the time? Clock diff, we didn't use clock diff here. Clock 2, positive edge reset. Oh, did I ripped out the complete block here? Oh, I have. No, here, there it is. Nice. That's cool. FPUs. Yeah, there is like what's really cool. When I was demo scene coding back in my time, where SSE and everything wasn't like, I don't know, okay, I think sometimes it was already supported by the compilers, but there is a mode, like you can set I think you could set the complete FPU to strict mode and non-strict mode. I'm not sure if it was the SSE extensions, but basically if you have like a division by 0, it wouldn't do not a number processing at all. You basically set everything to 0. So it's way faster if you don't have FPU exceptions. If I would ever use an FPU implementation, I would never like take care of the edge cases, like not a number or whatever, because I only use that for graphics, and you can't do graphics with infinite and not a number anymore. It's not, it's cells. We measured like, so I will get feedback if it's too large, and then we can basically change the word count here. Oh, you can see. We can set the word count to something that works, 48 or... Yeah, 64 times 8. Is this bad? So we have like space for, I think it was, hey Sion. We have space for, I think it was 1000, what was it? Flip-flops. or something like that, or 700 flip-flops. That's what we calculated. It's like, so yeah, no worries. No worries. I missed your stream yesterday. I started watching the beginning, but then I just wasn't able to concentrate really. What did you do on your live stream yesterday? Pi-hole? What is a Pi-hole setup? Raspberry Pi thingies? What is that? Okay. No, we don't do that. Oh, this is so mean. Clock. Agitator, okay. Oh no. Did you receive the parts from China already? Racked bits of that. What's racked bit? That's sad. Blah. Yeah, we don't need that. Okay, we can just do that. Okay. Least of my PNP issues. Oh no, what? What is happening all of the sudden? Or did you assemble stuff and then bit by bit everything fell apart? Okay, we need like a new... Okay, here we go. Okay, this is our clock 2 will be basically... Do you have power issues in your place, maybe? That sounds like some sort of... that might be like... If everything is dying, it sounds like a power issue. High voltage spikes or something. Flickering lights. Oh. No worries. Oh. One question, do you still have charm high? If not, they might want to sponsor you. Wire 7 0 out. You don't get anything on my stream. You won't get any ads except for tiny tape out today. Okay, why? What? No, this is one end operator. It ends everything. Here we go. That Yeah, I disable this here. This is my super mega hacker hack. If you want to uncomment, you just need to remove the first part and this part will still be. Yeah. Yeah. I learned this from a curse. I'm currently basically taking your donations and giving it to, so my highest patronage is currently to what is wrong with Discord? ocean conservation thing. That was, I saw them on TikTok. They're basically like catching seals, which are like have nets around the necks and cutting the nets off. And I like that. They're doing like really, really precious work. You love that channel? Ocean? No, I don't. They might have like ocean cleanup, but actually, I like they're helping like small seals that are like caught, like suffocating of nets and all the plastic, and they are basically releasing them from that stuff. And it's really like every time I watch that, on TikTok or whatever, I really like feel thankful for them doing such a work. OnlyFans channel. What's your? I don't have OnlyFans. I can't afford. I can't afford OnlyFans. I should set up my own OnlyFans. What? Oh wait, I have a syntax error. Yeah. Yes, that's the one. Ha! I think that's the one. At least they're not like really asking for their help, and I found one that basically had that linked. I'm not sure if that's the right one. Can't find object. Yeah, debug is not anymore. In, out, debug, no debug anymore. Oop. I need to clear that. I hate this output. Yeah, but paywall, I don't know. I'm bad at doing business, my friends. There isn't even like a big paywall on Patreon. You can. That's cool. I like that. Warning. That's cool. Module. Nur Lüfter. Should have an instance. Hey, Johnny! Oh, thank you. I didn't want to like get a pity super chat, but thank you very much. Thanks for the donation. Option 22 OP22. That's our module name. Here you go. That should work the same way. The same way it worked before, okay? If that still works, then we can... Nice, indeed. Okay, here we go. No worky. Wait, oh yeah, we don't have the debug output. Oh, here we go. 1, 2. 1, 2. 1, 2. Okay, it still works. It seems to work. It seems to work. Yeah, it's so simple. Okay, design works. Now I can shift. Okay, you will be live seeing how I shift 64 bytes here. and we will see our 2 bytes that we did before. I don't know. Ah! No! That's not more. The worst part is that we don't have... Oh, there it is! Look at this! And then we will see on, off, on, off, on. Yes! Oh, it was, yeah, on, off, on. Here we go! It works. Okay, let's put it in new module. This is my finger now. This is my button finger now. Okay, yeah, that's how you make an ASIC in... Oh yeah, I want to play Cyberpunk. Okay, here, let's do Verilog file. Option 22. V. Don't ask. Okay, here we go. Option 22 is now own file, and we can end module. Okay. Now I could let's get back. Tiny tape out. This is bitluni live test. Oh, Asbury, thank you very much. Oh, thank you. That's cool. Okay. Hi, I've been watching your videos for years. First time I've ever caught a live. Thank you for all the laughs and contagious enthusiasm. Yes. Yeah, I'm enthusiastic today as well for this here. Asbury. Asbury, is it? I think my headphones are dying. Okay. 0 battery remaining. Oh no. Okay, I can use 1 at a time. Yeah, today the mood was like really bad at the beginning of this FPGA stuff that didn't work, and now we are done. Oh, really? Oh, cool. Wait. Branch. Tiny tape out. Ah, wait. Ooh, here. How do I get there? Able to merge. Uh-oh. No, what did I do now? No. No, I don't want to pull request with my, oh shit. What did I, okay, here we go. Okay, I fork it again. Create 64, we probably can't fit even 64. Okay, it's not low res because how many angle, that's like every 6 degree 1 pixel. If you want a full circle, and also it will repeat, if you like increase the frequency of the clock, you will have like, yeah, I'll show you the design. This is the design. If we increase the frequency, everything will be basically repeating then. You have like a hard and a bit and hard and bit and hard and bit and hard and bit. And yes, I told you it will be like exponentially faster. View all folks, no more. Wait, I want. How do I fork again? Create a new fork. Ah, yes, here we go. New fork. Huh? Why? Why can I only fork it once? What? Oh no. But I want to rename that. Fork that. Okay. Let me check again. Fork. Create a new fork. Yeah. Fork. Yeah, but I don't want a branch because I submit the project and it will take the head, most probably. View all existing forks. No. Create a new fork. You are cool. Okay, you know what? Yeah, I'm screwed now. Okay, let's rename that basically. This is... Hey, how do I change? You're so cool. Spork. You're so funny. Create it? No. How do I change the name? Settings here, okay. It's not live tape, tiny tape out, option. Now it's renamed. Ha ha ha! And now, oh, and now I need to pull this. Oh no, good. Oh no. Yeah. Source. Maybe I should use add file, create a new file. Oh, src and top v. What? What do I wait for?
Live in bitluni hours.
Oh no.
So how I solve this is to create an organization. You can create as many as you like, and they can all have the same forks. All of it.
Uh-oh.
Et Davadarko nope. They are not branches, they are forks.
Uh-oh.
I mean, I guess if it's just committing this Verilog snippet, it's fine to use the online thing.
Sorry. I need to recharge my headphones. They are dead after 7 hours. Yeah, Pixel Buds died. Oh no. Okay. Yeah, I need to wait a second. I mean, it will take maybe a minute or two. But one of those should be all right. This one should be charged. Let me take it out.
Here's stereo, echo again, smiley face.
Okay, here we go.
Stream is sponsored.
Okay, right is 22% and left is charging. Okay, nice. Let's go. But I need to reconnect the chat, otherwise leave the chat. Oh. Okay, otherwise now I'm back. Okay, now I have you on my ear again. Shanghai pickles. Oh, where are the pickles? Did I eat them? I eated them. Okay, option 22. This is our yes, that's it. It's not a lottery, actually. You get your there's like this is not lottery thing. This is like a paid thing, but you pay I think $100 with the coupon code in, which is pinned in the ASIC channel. You get a discount, and if you want the board, it costs even I don't know what the actual price is right now. But you get it for sure. And these are the deadlines. Friday. Design. Oh, wait. Submit your design. Design only. So you get design plus physical. So design only, If you submit the design, it will be on the chip, but you won't get a piece then. What? There is no, like, I mean, this is then more sophisticated. I don't know. You need to read the specs here, the FAQs and specs. I can't answer all the stuff. I mean, Matt will help me. Try Matt's Discord, which was linked before when we started. And people, I don't know. I have no clue. On the Discord, you will, yeah, or check his Discord. There's like contact. I think that might be the Discord as well here. No, is it? He linked it before. Let me check it. If yeah, okay. So basically, you get all the information on his Discord. I can drop it here for the people who will be asking. Yeah, I mean, it's not a big project. It's a 7-hour project like I managed with my 0 skills. From 0 to pro to having an ASIC. This was Matt's Discord. Okay. So, option 22. Now we need to change settings. No, wait. Code. Then info YAML. So we change that. Source files. Source files must be, okay, so I will take the source files, projects, not project. Oh. Yeah. So this will be top module is option 22. There is an example. My Discord handle was linked before. Where's my Discord handle? Here we go. This is my Discord. Title, option 22. Description. Long shift. How do we describe it? Can you even see what I'm doing? Yes, you can. Yeah, winter hibernation struck me as well a little bit. I'm tired all the time. I don't know why. Maybe not drinking enough or What happened? Okay, okay. How it works? Long shift register for what? What is it? For that's the long. How it works? For in 0. Oh wait, there it is. We have inputs. A reset. Should we invert the reset here? Inputs reset. I hope it isn't pulled high. Okay, I will ask that, Matt. I might need to update it before Friday. But, right, then we have data in. What? People, what are you doing? Oh no. What happened? Are you diabetic or what? What's going on? Let what? It seems like many people suffering here. Okay, here we go. Yeah, me too. They're inverted? What is inverted? People are confusing. Okay, let's keep it like that. I will check the description. Okay, long shift display, how it works. Right. Yeah, let's keep it like that. Okay. Do so, please. Good luck, man. External hardware, how to test. Yeah, yeah, but you don't know actually. This description is optional. I just want to add this for the people. I don't know. There is like an example, Verilog, an example thing. You can use that. Basically, it has to be data in 8 and data out 8. Each full 8 bits will be. It will. The night wagon. Whew. Tough times. Okay. It will rotate through all words. Stored, yes, staged. I think there is like this, what I understand under staged is that you have like this buffer in between. It will be kept. Bye, Rota. Okay, this is our documentation. How to test. Use button as clock. Yeah. Oh, what? Yeah, true. Brits. Use button as oh, we have December. Ho ho ho. La 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 la. Oh, demonetized. Use button as clock. Keep right. High. And yeah, this is the external hardware not needed. Okay. Okay, now what? External hard. Yeah, that's good. Okay, okay. Okay. Yeah, that's like a meme here. Trolling people. Okay, external hardware. JIT. Pink. GIF. Yeah. JIT. Pink LEDs. But that's enough. Comment changes. Bye, Max. Okay, we are almost there. We just need to actions and commit, and that's all. Ah, look at this. It's process. Oh. Uh-oh. What doesn't it like? Gigabytes. What did I do wrong? What did I do wrong? Check. Okay, what did wrong? Okay, get out of docs here. GDS. Okay, I need to check the docs, but uh-oh. What doesn't it like? Might be. Okay, error. Block mapping starts. Oh, what? YAML? Is this like, is the YAML like Parsing block map. Oh, wait, I might have changed. Maybe project, tiny project information, project files. This is like two and two spaces, Shamon. Do we need like this project? What does it complain about? What does it complain about? Right? None. Okay. What was the issue? GDS here. It's processing. GQ. It's doing something. It's doing something. I have no clue what it's doing, but it's doing. Maybe we will see a rendering. Full complete, download complete. Now I'm really curious what the result is. Yeah, that's true. If this works, this will be sick. This will be sick if that works. Yeah, totally. I PDK and Caramel, no worries. It's like I'm doing this all the time, you know. That's what I usually do. PDK and Caramel. It seems to like doing something. It's okay. There is the YAML. No, it failed at YAML. Please don't tell Verilog build config. Oh no, please. Five. Column, line 3, column 1. Oh man, this is... Yeah. That's That's what I see. Okay, let me, what? Let me take an example. I mean, I know. Yeah. Stream quality, how's that possible? Wait a minute. This is... Oh. Can we just check out the... Wait. Wait, you mean like... This was the ID, but we don't use that. Source files. Let me just get let me just take an example from another fork. Where are the forks? How do I see the forks? View all existing forks and then submission. We just take option 22. Yeah, there isn't FIFO. Let's see the YAML. It's also WOC-wiki ID. We need some more complex demo nanoneuron. Also WOC-wiki. Oh, there is an VHDL example. Okay, let's see. Project 0. Okay. That's what the problem is. That's what the problem. This is source files should be indentation here. Option 22. This is fixed. Fixed GIF YAML. Yo, here we go. Come on. Really? People living on Twitter? How's that? Now we have to wait. Oh, really? Oh, Some people love to see the world burn. Oh, what was the update on Neuralink? I think he said he will update things there. Yeah, that's, you can really draw. Okay, I have a solution for my text to speech. I basically recharge one pixel while the other is being used.
I only get a few notifications on Twitter each day, so I'm not bombarded.
I need to rejoin because whenever the headphone... Oh, what is... Did it do the docs? The docs are fine. Okay, docs are fine now. We got the complete process. Oh, it was basically this is when you use spaces for like logic blocks. I think I changed, like, by deleting stuff, I changed like the indentation. Oh no, it failed. What was the fail there? What is with the run, traceback, fetch? Error key, key error, walkway key, process, int, walkway ID, okay. Oh, this is the old one. Oh, wait. Come on. Okay. Wait, is... Oh, yeah, it's commented out. So we need to have this in. Okay, sorry. Wait, cancel changes? What is... Yeah. One, two. Okay, here we go. I'm sorry, this is dreadful. Oh, she's probably rich, is she? Yeah, I know, I'm bitter. Okay, docs are fixed. Now GDS takes a while. Solo di Sabato. Eric, did you commit also as a design? Did you work with that before? Now the patience. But I like that everything is already automated. You don't have to do all this stuff by yourself. Yeah. Oh, okay. Yeah, that's helpful. To do it properly. Yeah, unfortunately, there are some parts that are really dreading. So from time to time, if we struggled with debouncing the button as the clock, and people got annoyed there, but I think we are on the path. And then quickly, once I debounced it with a huge buffer end, everything worked almost right away. Yeah, I've instead too. Oh yeah, I'm getting tired. Shoot. TikTok is cool. You can really like waste a lot of time on TikTok. Now, if you get like the right suggestions, I have so many makers and builders and whatever. Oh, it's setting up Python. It's running the YAMLs, fetching the build logs, generating. Hacker mode activated. Oh, now it's stuck. Oh no! Oh no! Oh. Yosis complains. What did Yosis? Results. Maybe we are too big. Option 22. Number of cells. Oh no. Number of cells 1,663. Oh no. Oh no. Oh no, it's probably too big. Where does it say? Chip area for module. 20,000 watts? Yeah, it probably generates the one addition. The buffer, yeah. The buffer is big, but What does it say? These are timings, or what is the actual violated? Violated. What is that? Max slew violation count. Fan out violation. What is that? West Slack. I have who knows what that means? Okay, there is a warning. Current core area is too small for power grid. The power grid will be minimized. Pins for I don't know. Oh, unmatched as errors exiting. What? Ah. The problem is the... Oh no, are you kidding me? This is the problem. Look at this. I think it just failed because I have unsigned inputs. Really? Yeah. Okay. The problem is that... Yeah, but I didn't know that it actually requires to have the stupid inputs be like all... I thought this was the standard. Okay, yeah, I mean, you have to do the... Whatever, let's do 3 then. Here we go. No worries. Okay, commit changes. No unused pins, and let's check the YAML again. Code. Yeah, okay, here we go. YAML is still fine. Now we need to wait for the actions again. Otherwise, you will just assign it to a wire that goes nowhere. Okay, documentation passed. Deployment takes a little bit, but I'm curious to see the result. This will never fit. This will never fit. They will complain. What's the size? What's the size? I have to check again with the specs. Otherwise, we might need to resubmit FAQ. Okay. How big can my design be? 90 by 120. I'm not sure if that's the current one because it was doubled. So 90 times 120, 10,800 square micrometers. That's the size. I mean, we were close. Haven't we been there like close? Let me check GDS from before. We saw the area. The area was somewhere. It seems like it's in this tool only. Wire bits. Interesting. Okay, number of wire bits. That's all right. Public wire bits. Number of cells. D flip-flop. Positive, negative. PN? No, PN, PP. Oh, that's like, what is that? P and another D flip-flop. This is strange. So this is probably for the register, for the counter. Some logic gates. This is like really odd. Okay. What do we see here? Statistics, wire bits. Where's my area? Serious business now. Oh no! It's too huge! Oh no! It's too huge! The max is like 10,000 chip area, but I don't know if it fits ASIC. It was either doubled or not. We will see what happens. This was the last GDS. We might be able only to use a buffer of 32 words. Yeah, that's microns most probably. Or is it nanos? What? What did it complain again about? 2 minutes? Okay. Error. Open road Python. Which unmatched? What? Yeah. Output in out. What is going on? What unmatched? Should I remove those? What is? Okay, let me go back to the remove these or what? This is, but I mean that worked with the other design before. Or is it like, okay, let me check. Oh, wait. Wait. No, look at this. It might be config, pin order config. No. Script here. What is... Okay, I don't know now what the issue is. I have no clue how to set the pins correctly. Maybe I need to, is there like a documentation? Wait. GitHub pages. Okay, how does it work? Resources. No, that's not the one. That's the FAQ. No, it's in groups. What are you testing? Your voice was so high-pitched. TCC to risk 5? Okay, cool. Okay, peeps. I need advice now from the pros because I don't know what the issue is. Okay, because my either I missed something. Top, option 22, in, out. We have in 0 until in 3 is assigned also. Out is used. Really? You sure? Let me check. Let me check. No. Nah. The module definition match. Okay. So I take an IO in, IO out. This is like I'm taking a look at an example. Here is an example like 4-bit CPU. So this is the top module. Yeah, look at this. That's what we use. This is if they have test bench. Interesting. Okay, in out 7 bits, and then really, which config in the YAML, info YAML or what? Which config? Look, it's like info work okay wiki ID. Interesting. Verilog. What is? Wait a minute. For YAML. That's the 4-bit CPU, and this is basically. Wait, did it link in the YAML title? Pop works, hardware. Verilog. What do I need to have it in MockWiki? Wait a minute, because there is like this MockWiki ID. So really? Oh no, it is wire. Okay. Yeah, that's like a random wiki. Okay. Okay, we changed this. We changed this, my friend. Okay, in. Oh no. Where does it say that? Oh wait, I need this a rack. Does it need to be rack or? I mean I want a rack there. Otherwise, I need a rack inside of my design. Ah. Okay, I will try it with rack. I will run it with. Okay, now I need to see IO in, out, out, out. Okay, let's try again. Yeah, mapping. I give you moderator rights, so you can also link stuff. Sam. Yeah, I will use rec then. And will automatically put this flip-flop inside of the module. No worries. Okay, here we go. Here we go. Okay. Let's see, let's see, let's see. Yeah, input and output will basically do this automatically. Oh wait. Did we delete in? Oh no. No, 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 no. That's wrong. We need input and output. Okay, this is important. It's probably just the name, okay? Now we need to rerun the actions again. Foo. I will kill my quota. We are trying to. I mean, it's like the last step before committing, and then we have to run again with a reduced count. It's always in the examples. In the examples, oh, where is it? Yeah. It's like this long ID name or something. ID number. V file. We have here our register, our shifting super register. Docs are okay? Yeah, docs are okay. This will be too damn huge, the design. Oh no, I wanted to end this at 1 o'clock and now it's past that. PDK and Caravelle. Set up Python. Oh, we are proceeding. Run pip YAML whatever. DD. Oh. Ah, it's running. Hacker mode activated. Oh no, it died. I have a syntax error now. Yeah. This is system Verilog. This is Verilog. Oh no. Oh, you found info. Okay. Yeah, probably. Okay, docs always succeed. Not difficult. Yeah. Yeah, now we got this. Now we got this. Let's just see. Ah, PDK and Caravelle. Here we go. Let show us the repo. Show us. It's doing the thing. And will succeed and fail because of the size. Here we go. Oh no! Error! What? What again? What again? Flow failed. Why though? Millions of lines of mapping and now you fail. What? Instance is not placed. Oh no. Instance is not placed. Where did it say it was too large? core is this? Where did it say it's too large? Use a higher density or reflow with larger core area. No! Oh no! I tried a few iterations to optimize it. Synthesis. Enhance, yeah. Okay, what do we do? How many tries do we want to? Okay, binary search. Okay, we do binary search. We try 32 next. 32. Okay, here we go. Too long. Commit. Yeah, we are almost there. Okay, 32. And if too fat. Okay, here we. Oh no. Yeah, we will see if we will look at the. We will do a binary search. If that succeeds, we can try 48. One and two commits in counting. Oh, Solo, these are Bato. You committed one? Really? No. Yeah, this is cool. This is cool. We need to be first to have ASIC design and actual deployment and manufacturing in our CVs before it's mainstream. Before PCBWay and JSC PCB has ASIC design in their portfolio. It said you need almost double the density. Yeah, but you know. Oh. Oh no. 30 bytes. Yeah, we are done on the FPGA. Christian, didn't you see it? This is our FPGA design. It works. Look, I will enter a byte here with write mode, set the bit 1 2 0 0 1 1 0, and here is the input. And it's stored. You can see it's too bright. Oh, wait, we have a camera here. Okay, this is my store. Oh no, it's parameterized. Yeah, you can see it. You were able to see it. Okay, you know the repo where you can check out my code and play around. Yeah, focus. Here you go. This is our day work. Our day. I mean, I did a lot more. So did I? Did I do? What did I do all day long? Oh, it's already. Oh, it failed again. Please don't tell me it's too big again. Oh no. What is this? What does it say? Flow. Ah, for a power grid. The power grid will be minimized. Oh no. Routing congestion. Why though? You just need a loop, like a snake. Oh man, the router, the auto routing software basically fails. You know what? It never played like Stau on the Autobahn. It never played Snake. You know when you play like Snake for really long, and you have like filled all the screen with one snake. How much overflow? Timing issues. What do you suggest? RS flip-flops. SRAM. We just need SRAM. Okay, but how does... Yeah, maybe. Okay. Let's not give up. Let's first of all, let's try to make something working, okay? Let's try 16. That's like 3 letters. How many? Okay. Okay. How many bytes do we need to... Okay, let's try 16 now. But this is not even bitluni. How many characters? bitluni. That's like 6. Oh, that's 48. If the characters are 6 times 7, it's... Oh shit. That's no good. I can't even display bitluni right now. This display. It's only the bit, a hard and a bit. So we need... So we have 5. Oh no. Oh no. No, output is not. You know what? The adder is probably... Yeah, this is like... yeah, let's just run it and see what happens. Yeah, I can do like 5. Yeah, yeah. No, we could do like the POV. We can remove like 3 bits. We don't need like all like 8 bits wide. We could clock in 5 bits. But then what do we clock in? Like, oh no, then we have to like this will give us different problems. What is too long? GTS. Okay. Okay, let's see. Parametric design, peoples. 16-byte buffer. No, this is, and people made like FPGAs in that. What do you mean? Add buffer as an array? What do you mean? No, I didn't, because I'm always shifting by 1 bit, so why? Yeah, no. Doesn't. Does it really matter? Okay, here we go. Moment of truth. But we can't write 8 bits at a time. Like the input, we will see what the output says, like how it looks right now. We will see at the design right now. Now, I think this is a really interesting part of that process now. I mean, no. We are always shifting 1 bit. That's the only way we can work right now. What is that? Completing 60% with violations. What violation? Oh no. What does the violation mean? Does it mean it doesn't work at the end? No, no, I don't. Not really, no. I mean, we could change the whole thing and shift a complete byte. The only thing that we can do is use the counter to address a byte, but that makes the logic way more complicated at the beginning. But if it helps with the routing, then it might be, because shifting a whole byte at once, we can even use the output register as one of the storage bytes. Yeah, we will see, we will see, we will see, we will see. Then we have to rewrite the whole code. Yeah, that's what's happened. We have the latch, so we can. Hey, Dutch Maker, yes, you did. Completing 90%. How long will it try to optimize that? It's still running. How many violations? $87, and that was yeah. Yeah, that's what we can do, is use the counter to shift in the bit. But oh, it's done. It's done. It's completed. It's rendering PNG now. Okay. Ah. What was that? Viewer. Yeah, we have 16 bytes. 64 is way better. Let's try. Okay. I mean, I can end the stream and then start optimizing. Cool, cool. Yeah. Pages. It's still preview. How do I? It's rendering the preview. How do I see the? I forgot. How do I? Where was the rendering? Here. Okay. Yeah, it looks like it could fit maybe 32. It's not the smallest, but we have like a lot of real estate here. Look at that. YouTube play button. Okay, I think this is satisfying now. I will try to run it again. I will try to you can fork it and try. Yeah, this is like yeah, it's committable now. Okay, and now I just take my fork off here, bitluni, GitHub bitluni option 22, and commit. Here we go. Where is the commit button? Wait, tiny type out. Where is this? Yeah. Yeah, I will do that. I will do that, but I will just try what happens. Oh wait. Cool. Okay. Look at this. And we get how much off with our coupon code? The coupon code was, it's on Discord. I don't want to spoil it here. It's mental broad, yeah. Here, oh, 24. Oh yes, that's cool. Okay, $24 off coupon code. So you can wait. Can you use this for design slot only to submit for $1? I think that's cool. That's really cool. Okay. People, this is cool. Okay. I will try to maximize the space next. This is not my design. My design is wake. Did I? No, I don't. I'm not ordering online. Okay, peeps. This went better than expected. I mean, we had. So what's happening here again? We had some hiccups with some stuff, but it really looks cool. And I will try to somehow fit 32 bytes at least. Yeah, it was. Okay. Yeah, that's true. That's true. Oh man, this is like ASIC design. What? Peeps, this is cool. We have Matt brought us and all the people that contributed brought us how do I add the screen capture? Screen capture, bam. Okay. Brought us these fancy tools, the GitHub Actions, and this yeah. Yeah, I will do the 8-bit, but this I need like I will let you know how many bytes I was able to fit in at the end. Currently we are at 16 with this mess, but there is a lot of real estate here, a lot free space here and there and whatnot. I will change it to use 8-bit registers, and I will use my fancy clock here. Now it's clocked away. And that's it for today. Thank you, everyone. Bye bye. Have fun. Try out. You can also try easy designs. We have coupon codes. Easy. You don't need even like here. You can do it like that and submit this as well. It's it's even simpler than what I did. Have fun. Deadline is on Friday. I want to see more designs. Bye bye. Yeah. Close. Okay. Yeah. We made it. We have an ASIC design. What? An ASIC design that I don't know if it works. It might work. Who knows? We will commit. We will commit to this design and test it in half a year. Bye bye.